All right, let's take a look at the practice test. We want to use the fundamental identities to find the missing trig ratios. And for the first problem, we're going to have that the cotangent of theta is equal to negative 15 over 8, and then the sine of theta is less than 0. So the first thing you'd want to do is figure out in what quadrant does theta lie. So just take these two pieces of information. The cotangent of theta is negative, and the sine of theta is also negative. So where's that going to happen? Well, cotangent is negative in quadrants 2 and 4, and sine is negative in quadrants 3 and 4. So the overlap would be quadrant 4. So let's go ahead and say that theta is in quadrant 4, just so we have that information in terms of the signs for all your trigonometric functions. Now, the next thing you would do is just figure out all the missing guys that you need. So I'm going to start off by just going to another page, and I'm going to write that theta, again, is in quadrant 4, so we don't forget. And we already know that the cotangent of theta is equal to negative 15 over 8. And so that tells me that the tangent of theta, so the tangent of theta is equal to, remember, you could just take the reciprocal of this. So it's the negative of 8 over 15. So those two are done. So the next one I would get would be, let's go ahead and do the sine of theta. And then the reciprocal of that would be the cosecant of theta. I'm just going to pull up my little identity handout here. And again, this is in this section if you want to use it as a reference. And I'm just going to scroll through and I'm going to look for something that would help me. Now, there are multiple ways that you could solve this type of problem. What I'm going to do is I'm going to work with this guy right here. So 1 plus cotangent squared theta is equal to cosecant squared theta. Remember that cosecant and sine are reciprocals. So let's take that guy right there. So 1 plus cotangent squared theta is equal to cosecant squared theta. And we're just going to plug in. We know what cotangent of theta is, but remember this notation a lot of times will trip up students. This guy is like having the cotangent of theta being squared. So your cotangent of theta is negative 15 over 8, so you would plug that in and then you would square it. So let me get rid of this. And I'll plug that in, so negative 15 over 8, and this is squared. Let me scroll down and get some room, I'll come back up. And so if I square this, I'll have 1 plus negative 15 being squared is 225, and 8 being squared is 64, and this equals your cosecant squared theta. So let's get a common denominator here. I would multiply 1 by 64 over 64. So this is 64 over 64. And just for convenience, I'm going to flip the sides here, and I'll go ahead and say that cosecant squared theta is equal to 64 plus 225. That's going to give me 289. This is over the common denominator of 64. Now from here, I'm just going to use my square root property, but remember, we're in quadrant 4. So cosecant and then also sine would be negative. So I want the negative square root over here. Okay, so I want to say that the cosecant of theta is equal to the negative of the square root of 289 over 64. And so I'll end up saying that the cosecant of theta is equal to, you'll have, if you think about the square root of 289, that's 17, and the square root of 64 is 8. So this is the negative of 17 over 8. And I'll just write it right here. So this is negative 17 over 8. And of course, if we want the sine of theta, just take the reciprocal of this. So this would be negative 8 over 17. Now, we still need our cosine of theta, and we need our secant of theta. So what can we use for this? Again, a lot of different strategies, but I would use the identity where we say that sine squared theta plus cosine squared theta equals 1. So let's come down here and say that your sine of theta is negative 8 over 17. So you would want, let me write this out first. So sine squared theta plus cosine squared theta is equal to 1. Plug in for the sine of theta, that's negative 8 over 17. And then we are squaring this. Then plus your cosine squared theta is equal to 1. So from here, I'll just say that cosine squared theta is equal to 1 minus, go ahead and square this. So negative 8 squared is going to be 64. And then 17 squared is 289. Let's get a common denominator. So I can multiply 1 by 289 over 289. And then I could do 289 minus 64. That's going to be 225. So let's say that this is cosine squared theta is going to be equal to 225 over that common denominator of 289. And then we'll say that the cosine of theta is equal to, remember, we are in quadrant 4, and in quadrant 4, cosine and also secant are going to be positive. So I want the principal square root of 225 over 289. So just using my square root property, but again, instead of the plus or minus here, you want to think about what quadrant you're in. We're in quadrant 4, cosine's positive, so that's why I want the principal square root. So then I want cosine of theta to be equal to, the square root of 225 is 15, the square root of 289 is 17. So that's my cosine of theta. So coming back up here, let me write this more neatly. The cosine of theta is 15 over 17. And the secant of theta, again, just take the reciprocal. This would be 17 over 15. So we have everything. Again, we know that theta is in quadrant 4 based on the information given. We know that cotangent of theta is equal to the negative of 15 over 8. That was given to us. The tangent of theta, that's the reciprocal of the cotangent of theta. That's the negative of 8 over 15. The sine of theta is negative 8 over 17. The cosecant of theta, again, you can take the reciprocal of this. It's negative 17 over 8. The cosine of theta is equal to 15 over 17. And then the secant of theta, again, take the reciprocal of this, is 17 over 15. All right, let's take a look at problem number 2. So here we have the cosecant of theta is equal to negative 5 over 3. And then we have the cosine of theta is greater than 0, or you could say positive. So where is the cosecant of theta negative? Well, again, cosecant and sine are going to be reciprocals. They are both negative in quadrants 3 and 4. Then for the cosine of theta, it's going to be positive in quadrants 1 and 4. So once again, we know the overlap here is going to be in quadrant 4. So we'll just say that theta is in, let me say, quadrant 4. So from here, I'm going to start out by just writing this information on the next page. So the cosecant of theta is equal to negative 5 over 3. So we'll say that, again, theta is in quadrant 4, so we don't forget that. And your cosecant of theta is equal to negative 5 over 3. Now we know that if we take the reciprocal of our cosecant of theta, we'll have the sine of theta. So this would be negative 3 over 5. And then let's work on the cosine of theta, and we'll take the reciprocal of that to get our secant of theta. And so let's go back to the handout. Again, I'm just going to use this right here, sine squared theta plus cosine squared theta equals 1. I think that's one you're going to memorize pretty quickly. So let's just write that out real quick. We have sine squared theta plus cosine squared theta is equal to 1. So I'm just going to plug in for the sine of theta. So that's negative 3/5. So negative 3/5. And we're going to square that. Then plus we have cosine squared theta, and this equals 1. Okay, so I'm just going to write this as cosine squared theta is equal to 1 minus, go ahead and square this guy, negative 3 squared is positive 9. And then 5 squared is going to be 25. Let's just get a common denominator now. So I could write 1 as 25 over 25. Let me slide down here just a little bit. So I have my cosine squared theta is equal to 25 minus 9 is 16. So this would be 16 over the common denominator of 25. Now again, we are in quadrant 4. So when I use my square root property, I'm going to say that the cosine of theta is equal to the principal square root of 16 over 25. So again, you don't want the negative square root there because you're in quadrant 4 and cosine is going to be positive. So from here, we'll say that the cosine of theta is equal to, the square root of 16 would be 4, and the square root of 25 would be 5. So my cosine of theta is 4/5. Okay, so let's come back up here and put the cosine of theta is 4/5. Your secant of theta, again, you can just find the reciprocal of this, so that would be 5/4. Now for the tangent of theta, and then the cotangent of theta, there's a lot of different strategies you could use. What I'm going to do, let's just go back to the handout. If we scroll up a little bit, you notice you have these quotient identities that we talked about before. So the tangent of theta is the sine of theta over the cosine of theta, and the cotangent of theta is the cosine of theta over the sine of theta. I think that's probably the easiest thing to use here. For the tangent of theta, this is my sine of theta over my cosine of theta. Now, my sine of theta is negative 3/5. So let me put that in here. And my cosine of theta is 4/5. So let me put that in here. And we know how to divide fractions. You're going to take this guy right here, this negative 3/5. Let's write that off to the left. And then I'll put times. Let me make this 3 a little bit better here. I'm going to take the reciprocal of this. So this will be 5 over 4 here. So I'll cancel this common factor of 5. And we'll say this is going to be negative 3/4. So I'll put negative 3/4 here. And of course, for the cotangent of theta, just find the reciprocal of this. So this is negative 4/3. So again, we figured out that theta was in quadrant 4. we were given that the cosecant of theta is negative 5 over 3. Then the sine of theta is negative 3 over 5. The cosine of theta is 4/5. The secant of theta is 5/4. And the tangent of theta is negative 3/4. The cotangent of theta is negative 4/3. All right, let's take a look at problem number 3 now. So here we have that the tangent of theta is 3/4 and the cosine of theta is less than 0, or you could say negative. So if we think about our tangent function, it's positive in quadrants 1 and 3. The cosine function is going to be negative in quadrants 2 and 3. So the overlap here is going to be quadrant 3. So let's say that theta is in quadrant number 3. And we can even write this down here. So we'll say that theta is in quadrant 3. Okay, so we're given the fact that the tangent of theta is equal to 3/4. And of course, the cotangent of theta is equal to, you could just take the reciprocal of this, so it's 4/3. We're just going to go to the identities handout. And personally, if I have tangent, then I'll just use this one right here. Or if you want, you could use this one right here. You have cotangent as well. But it's just personal preference. I'm going to use tangent squared theta plus 1 equals secant squared theta. So tangent squared theta plus 1 is equal to secant squared theta. Okay, so I'm just going to plug in for tangent of theta. That's going to be 3/4. And of course, this is squared, so this is 3/4 squared. So let me put 3/4 squared like this. I'll just flip this around and say secant squared theta is equal to, if I square this, 3 squared is 9, 4 squared is 16, so 9 over 16, and then plus this 1. If I want a common denominator, I'll write this as 16 over 16. Let me get rid of this. We're not going to need that anymore. Let me slide down here just a little bit. Just remember, you're in quadrant 3. And in quadrant 3, your secant and also your cosine, those are going to be negative. So let's say that this is secant squared theta is equal to 9 plus 16, which is 25, over the common denominator of 16. And again, when we use our square root property, we'll say the secant of theta is equal to, I want the negative square root here because again, I'm in quadrant 3 and my secant is going to be negative. So the negative of the square root of 25 over 16. And if I take the square root of 25 over 16, the square root of 25 is 5, the square root of 16 is 4. So the secant of theta is equal to the negative of 5 over 4. So we'll say that the secant of theta is equal to negative 5 over 4. So of course, the cosine of theta, which is the reciprocal of your secant of theta, would be negative 4/5. Okay, we're going to find our sine of theta, and we're going to find the reciprocal of that and get the cosecant of theta. Again, there's so many ways to do this. I'm just going to use the sine squared theta plus cosine squared theta equals 1. So sine squared theta plus cosine squared theta equals 1. And if you want, you could just solve this for sine squared theta right now. Typically, a lot of people will do that, and they'll just say that sine squared theta is equal to 1 minus cosine squared theta. And for the cosine of theta, I'm going to plug in a negative 4/5, and that's going to be squared. So let me plug in negative 4/5, and this is squared. So let me come down here. We'll come back up in a moment. So this negative 4 being squared is 16, and 5 being squared is 25. So let's write sine squared theta is equal to 1 minus, this would be 16 over 25. Let's get a common denominator going. So I'll write 1 as 25 over 25. And we'll say that sine squared theta is equal to 25 minus 16 is going to be 9. So this is 9 over 25. Okay, let me slide this up here. And we know that, again, we're in quadrant 3. So in quadrant 3, we know that sine and cosecant are both going to be negative. So for the next step, I'm going to use my square root property. I'll just say that the sine of theta is equal to the negative, again, because I'm in quadrant 3, of the square root of 9 over 25. Now, if I think about the square root of 9 over 25, the square root of 9 is 3, the square root of 25 is 5, so you have the negative there, so this is negative 3/5. So the sine of theta is negative 3/5. Now, if I want the cosecant of theta, again, just find the reciprocal of this, so this is negative 5/3. So again, we found that theta was in quadrant 3. where we're given the fact that the tangent of theta was 3/4. We found that the cotangent of theta was 4/3. The cosine of theta was negative 4/5. The secant of theta was negative 5/4. The sine of theta was negative 3/5. And the cosecant of theta, that's going to be negative 5/3. Okay, let's take a look at problem 4. So here we have our sine of theta is equal to 7/11, and then our cosine of theta is greater than 0 or positive. So for sine to be positive and cosine to be positive, you have to be in quadrant 1, right? Sine is positive in quadrants 1 and 2. Cosine is positive in quadrants 1 and 4. So the overlap is going to be in quadrant 1. So let's come down here and say that theta is in quadrant 1. And then I'll also note what we're given, which is that the sine of theta is equal to 7/11. And so we know that the cosecant of theta, again, which is the reciprocal of your sine of theta, is 11/7. So now let's think about finding the cosine of theta and our secant of theta next. So we already know our identity. That's the sine squared theta plus cosine squared theta is equal to 1. Since you want cosine of theta, you can write this again in the alternative form. So you see this a lot. So cosine squared theta is equal to 1 minus the sine squared theta. So you'll work with that form a lot. And then basically I'm just going to plug in for my sine of theta, and then I need to square it. So the sine of theta is 7/11. So this is 7/11, and we are going to square that. All right, we'll come back up in a moment. So let's write the cosine squared theta is equal to 1 minus 7 squared is 49. 11 squared is 121. And then if I think about this guy, I would just get a common denominator. So this is going to be 121 over 121. So 121 minus 49, that's going to give me 72. So let's say that this is going to be cosine squared theta is equal to 72 over 121. Now we know we're in quadrant 1. We've already established that. So when I use my square root property, I'm just going to say that this is the cosine of theta is equal to, I want the principal square root, because again, cosine will be positive in quadrant 1, of this 72 over 121. Now this one I would break up, and I would say that this is going to be the square root of 72 over the square root of 121. We know that the square root of 121 is 11. So let me just write that down here. We can forget about it. For the square root of 72, let's write that as the square root of 36 times the square root of 2. So the square root of 36 is 6, and then times the square root of 2. You can't do anything with the square root of 2, so this is over 11. So that's going to be my cosine of theta. So this is 6 times square root of 2 over 11. And let's think about the secant of theta now. So I'm just going to find the reciprocal of this. So we have 11 over 6 times square root of 2. Now, you never want to leave a radical in the denominator. So again, we just rationalize the denominator to get rid of this. So we're going to multiply by the square root of 2 over the square root of 2. So you're going to get 11 times square root of 2 over basically 6 times 2, which is 12. So 11 times square root of 2 over 12. So let's put 11 times square root of 2 over 12. Okay, now let's find the tangent of theta, and we'll find our cotangent of theta. So we saw earlier that the tangent of theta is the sine of theta divided by the cosine of theta. Again, since we haven't worked with that one that much, I'll just pull it back up. The tangent of theta is the sine of theta over the cosine of theta. So let's write our tangent of theta is equal to the sine of theta over the cosine of theta. And for the sine of theta, that's 7 over 11. So 7 over 11. For the cosine of theta, this is 6 times square root of 2 over 11. So this is 7 over 11 times the reciprocal of this, which is 11 over 6 times square root of 2. Let me actually get rid of this step here and slide this down so I have enough room. Or actually, I can just come down just a little bit and I'll come back up. So this would be equal to, this is an 11 here, it's just poorly written. So let me make that more clear. This will cancel. So you have 7 over 6 times square root of 2. Again, you would want to rationalize the denominator, but before you do that, remember, the cotangent of theta is found by just taking the reciprocal of this. So I'm just going to write this right now as 6 times square root of 2 over 7. Otherwise, I'm going to have to double work. So now what I'll do is I'll just multiply this by the square root of 2 over the square root of 2. And so that would give me 7 times square root of 2 over square root of 2 times square root of 2 is 2, and times 6 is 12. So 7 times square root of 2 over 12. Okay, let's get rid of all of this. And I can just slide this up here for my answer. And I'll just come back up here. We found that theta was in quadrant 1. So your sine of theta is given as 7 over 11. Cosecant of theta is going to be 11 over 7. Cosine of theta is 6 times square root of 2 over 11. Secant of theta is 11 times square root of 2 over 12. Your tangent of theta is 7 times square root of 2 over 12. And then finally, your cotangent of theta is going to be 6 times square root of 2 over 7. All right, let's take a look at problem 5. So we have the cotangent of theta is equal to 2 times square root of 2, and the cosine of theta is greater than 0. So cotangent is going to be positive in quadrants 1 and 3, and then cosine is positive in quadrants 1 and 4. So the overlap is in quadrant 1. So we'll say that theta is in quadrant 1. So all of our trigonometric functions are positive, and we're also given that the cotangent of theta is 2 times square root of 2. So we'll say that the cotangent, or actually, let me write this over here. So we'll say that the cotangent of theta is equal to 2 times square root of 2. All right, so we know that the tangent of theta is equal to, again, I'm just going to take the reciprocal of this. So this would be 1 over 2 times square root of 2. And you want to rationalize the denominator. So let's multiply by the square root of 2 over the square root of 2. So this would be the square root of 2 in the numerator. Let me just get rid of that for right now. So the square root of 2 up here. And then square root of 2 times square root of 2 is 2. And then 2 times 2 would be 4. So this is the square root of 2 over 4. Again, just going back to our little handout, you could use this guy right here, tangent squared theta plus 1 equals secant squared theta. So you'd have secant, and then you could also find cosine. Or you could do this one, 1 plus cotangent squared theta is equal to cosecant squared theta. So that would give you your cosecant and your sine. Now, I'm just going to use this one, but if you want to use the other one, it really doesn't matter. You get the same answer either way. So let's start with tangent squared theta plus 1 is equal to secant squared theta. And I'm just going to plug in for the tangent of theta. So square root of 2 over 4. And then we need to square that. So this is the square root of 2 over 4. And we're going to square that. Let's just come down here. So the square root of 2 squared is going to be 2. And then 4 squared is going to be 16. So you can reduce this fraction. You have a common factor of 2. So this would end up being 1/8 if you simplify. So then plus 1. Let's write this with a common denominator. So 8 over 8. So this is equal to, let me just put this over here. We'll have our secant squared theta. So we'll just say that secant squared theta is equal to 1 plus 8 is 9 over your common denominator of 8. Now we are in quadrant 1. So when I use my square root property, I'll say the secant of theta is equal to the principal square root of 9 over 8, which is equal to the square root of 9 over the square root of 8. So the square root of 9 is 3. For the square root of 8, remember that's going to be the square root of 4, which is 2 times the square root of 2. We do want to rationalize the denominator, but before you do this, remember, for the secant of theta and the cosine of theta, they are reciprocals. So before you rationalize the denominator, what you could do is say that the cosine of theta is equal to, just flip this now, save yourself a little bit of work. This is going to be 2 times square root of 2 over 3, and I'll slide this all the way up. Okay, let me put a comma, and we'll have our secant of theta is equal to, I'm just going to rationalize the denominator here. So what I'll do is just say this is multiplied by the square root of 2 over the square root of 2. So 3 times square root of 2. So 3 times square root of 2 over, you have 2 multiplied by square root of 2 times square root of 2. So square root of 2 times square root of 2 is 2, and then 2 times 2 is 4. So after we rationalize the denominator, we get 3 times square root of 2 over 4 for the secant of theta. Now, we want to figure out the sine of theta, and we want to figure out the cosecant of theta. Now, you could go back here and use this guy right here. A lot of people use sine squared theta plus cosine squared theta equals 1. It's very easy to memorize that because you use it so often. But just to get a little practice working with something else, let's use this guy right here. So we have the quotient identities, tangent of theta equals sine of theta over cosine of theta. So let's write that out real quick, that the tangent of theta is equal to the sine of theta over the cosine of theta. Now, if I want sine of theta, then what I could do is multiply both sides by the cosine of theta to clear out this denominator here. So let's put that over there. And so this would cancel, and you'd have the sine of theta is equal to the cosine of theta times the tangent of theta. So that's something we use pretty often. So for the tangent of theta, that's square root of 2 over 4. So this is square root of 2 over 4. For the cosine of theta, this is going to be 2 times square root of 2 over 3. I'm going to run out of room, so let me slide down here real quick and see what we can do. So we see that this guy and this guy, there's a common factor of 2. So let me write a 1 up here. Square root of 2 times square root of 2 is going to be 2. So if I had 2 over 2, that would be 1. So in other words, I can cancel this and this. So square root of 2 times square root of 2 would be 2 with this 2 right here. Okay, so that's what I'm doing. So you're going to end up with 1/3 for the sine of theta. Okay, and if you need to write that out, you can go 2 times square root of 2 times square root of 2 over 3 times 4. I know somebody's going to be confused. And then you could say this is 2 times 2 over 3 times 4. And you could say this is 4 over 3 times 4 and cancel this with this and say that this is 1/3, just in case anybody's lost. And we'll say this is 1/3. And of course, for the cosecant of theta, just take the reciprocal. So that's 3 over 1 or just 3. So we found that theta was in quadrant 1. The tangent of theta is square root of 2 over 4. The cotangent of theta is 2 times square root of 2. The cosine of theta is 2 times square root of 2 over 3. The secant of theta is 3 times square root of 2 over 4. The sine of theta is 1/3. And the cosecant of theta is 3. Okay, let's take a look at problem number 6. So here we have the secant of theta is equal to square root of 10 over 3, and the sine of theta is less than 0 or negative. So for sine to be negative, you're in quadrant 3 or you're in quadrant 4. For secant to be positive, you have to be in quadrant 1 or 4. So the overlap is quadrant 4. So let me come down here and say that theta is in quadrant 4. We see that for the secant of theta, this is square root of 10 over 3. So the secant of theta is square root of 10 over 3. So that means my cosine of theta is going to be 3 over the square root of 10. And of course, we're going to rationalize the denominator here. So I'm going to multiply by the square root of 10. And I did that terribly. So square root of 10 over square root of 10. So this would be 3 times square root of 10 over 10. So this is 3 times the square root of 10 over 10. We have the secant of theta. So let's come down here and think about what else we could figure out. Well, if we have the secant of theta, well, we could plug in here and find the tangent of theta. Let's just do it that way. So tangent squared theta plus 1 equals secant squared theta, just to get a little change up. So tangent squared theta plus 1 equals secant squared theta. So what I'll do is subtract 1 away from each side. I'll get rid of this from over here. And I'll just plug in for the secant of theta. That's going to be square root of 10 over 3. So this is square root of 10 over 3, and we need to square that. So let's say that the tangent squared theta is equal to square root of 10 squared is going to be 10. 3 squared is going to be 9. I'm subtracting away 1, but let's write this as 9 over 9. So let me erase this, and I'll say that tangent squared theta is equal to 10 minus 9 is 1 over the common denominator of 9. And then because we're in quadrant 4, remember your tangent is going to be negative there. So I want to say tangent of theta is equal to, I want the negative square root of 1/9. Again, with your square root property, it's plus or minus. But here, because we're in quadrant 4 and tangent is negative, you want the negative square root of 1/9. So that's going to be the negative of the square root of 1, which is 1, over the square root of 9, which is 3. So this is negative 1/3. And I'll say that the tangent of theta is equal to negative 1/3. And of course, just take the reciprocal of this and find the cotangent of theta. So this is negative 3 over 1 or just negative 3. So just a different way to find stuff. What else could we do if we wanted to find the sine of theta and the cosecant of theta? We know we can use cosine squared theta plus sine squared theta equals 1. But again, let's just mix it up a little bit. If we go back, we used this one already. Let's use this one. So we have the cotangent of theta is cosine of theta over sine of theta. So let's say the cotangent of theta is equal to the cosine of theta over the sine of theta. So again, if I'm trying to find the sine of theta, well, what I could do is write this over 1 and cross multiply. So you'd have the sine of theta times the cotangent of theta is equal to the cosine of theta. And I'm going to divide both sides by the cotangent of theta. So let me get rid of this, and I'll say that the sine of theta is equal to your cosine of theta divided by your cotangent of theta. So that nobody's lost, all I did was divide both sides by the cotangent of theta, just so I could get the sine of theta by itself, and that's what I did. Okay, let's get rid of this. We're just going to use this guy now. So the cosine of theta is going to be 3 times square root of 10. So 3 times square root of 10 over 10. The cotangent of theta is negative 3. Let's just write that as negative 3 over 1. So this equals, we're going to keep this guy the same. So 3 times square root of 10 over 10. I'm going to take the reciprocal of this guy. So this is times 1 over negative 3. So we'll cancel this with this. And basically what I'm going to have is negative square root of 10 over 10. Okay, so negative square root of 10 over 10. So that's my sine of theta. So negative square root of 10 over 10. And then for your cosecant of theta, this is the negative 10 over square root of 10. And you need to rationalize the denominator there. So I'll say this is times the square root of 10. And this is times the square root of 10. So square root of 10 times square root of 10 would give you 10. So let me write that there. And then we're going to cancel a common factor of 10 between the numerator and denominator. So this is basically the negative of the square root of 10. So the cosecant of theta is the negative of the square root of 10. So again, we found that theta is in quadrant 4. Your cosine of theta is 3 times square root of 10 over 10. Your secant of theta is square root of 10 over 3. Your tangent of theta is negative 1/3. Your cotangent of theta is negative 3. Your sine of theta is negative square root of 10 over 10. Your cosecant of theta is negative square root of 10. Okay, let's take a look at problem 7 now. So we are told to write sine of theta in terms of cosine of theta. So if you get this problem on your homework or for a test, it's a very common problem. Just go back to your identities handout and use that sine squared theta plus cosine squared theta equals 1. You're just going to solve for the sine of theta. Okay, so that's what they're asking you to do there. So let's put this as sine squared theta plus cosine squared theta is equal to 1. Let's slide down just a little bit. And what I'll do is subtract the cosine squared theta away from each side of the equation. And we will have sine squared theta is equal to 1 minus cosine squared theta. So this is just another form of this identity, but we want to solve this for sine of theta. We don't want sine squared theta. So what I'm going to do here is basically use my square root property. So we could say that the sine of theta is equal to plus or minus the square root of 1 minus cosine squared theta. Now this is basically all you can do. You don't have any information about the quadrant you're in. So essentially you need that plus or minus here out in front of this square root. So to write sine of theta in terms of cosine of theta, you want to say the sine of theta is equal to plus or minus the square root of 1 minus cosine squared theta. Okay, let's take a look at problem 8, which is similar to problem 7. So this is something you might also get. It's very common. We want to write tangent of theta in terms of secant of theta. Okay, let's go back to our little handout. And if we look at this guy right here, we have tangent squared theta plus 1 equals secant squared theta. So let's copy that. We have tangent squared theta plus 1 is equal to secant squared theta. So again, I just want to solve for tangent of theta, and it's in terms of secant of theta. So my first step is to subtract 1 away from each side. So we'll say that tangent squared theta is equal to the secant squared theta minus 1. And then from here, I'm just going to use my square root property. So I'll say the tangent of theta is equal to, again, don't forget the plus or minus in this scenario. We don't have any information about the quadrant we're in. So this is the square root of this guy right here. So secant squared theta minus 1. So very simple. To write the tangent of theta in terms of the secant of theta, you get tangent of theta is equal to plus or minus the square root of secant squared theta minus 1. All right, for the next two problems, we're asked to write in terms of sine and cosine, remove all quotients. All right, so let's take a look at problem number 9. We have sine squared theta times the quantity cosecant squared theta minus 1. Essentially, what you want to do is look for an identity that's going to allow you to substitute here. So let's go to our little page here. And if I look for something with cosecant squared theta, I have that right there. So 1 plus cotangent squared theta equals cosecant squared theta. So 1 plus cotangent squared theta is equal to cosecant squared theta. Now you might look at this in this form and say, well, this doesn't match this. But just do a little bit of algebraic manipulation. So just look for something that has cosecant squared theta in it. So you found that. You're going to do a little bit of algebraic manipulation. And I'm just going to subtract 1 away from each side. And that would give me that the cotangent squared theta is equal to cosecant squared theta minus 1. So I'm just going to plug in here. And so I'll say that this is cotangent squared theta. So let's say that now we have sine squared theta, and I'll put this as equal to, times our cotangent squared theta. So at this point, I know that the cotangent of theta, again, just going back, is cosine of theta over sine of theta. So let's go ahead and write that this is going to be my sine squared theta times, I'll say this is cosine squared theta over sine squared theta. Look at this, we can cancel sine squared theta with sine squared theta, and we are left with cosine squared theta. Okay, so this is the answer that we're looking for. All right, let's take a look at problem 10. So here we have 1 minus cosine squared of negative theta over 1 plus tangent squared of negative theta. And again, I would go to the little handout that we have, and we look at negative angle identities, or some books call these the even odd identities. Remember, cosine is an even function, so the cosine of negative theta is equal to the cosine of theta. And then tangent is an odd function, so the tangent of negative theta is equal to the negative of the tangent of theta. Okay, so coming back up here, I'm just going to use that property to replace this guy right here and say this is 1 minus cosine squared theta. Okay, let me put this over here like this. Now for this one, I won't replace it yet. A lot of people would say this is 1 minus tangent squared theta. But instead of doing that, let's just keep it as 1 plus tangent squared of negative theta. And the reason I'm going to do that, if we go back to the Pythagorean identities, tangent squared theta plus 1 is secant squared theta. Okay, so what I'm going to do is say that that's equal to the secant squared of negative theta. So I'm just going to make a replacement there and say this is equal to 1 minus cosine squared theta over, this would be secant squared of negative theta. Now again, secant is an even function. So I can say that the secant squared of negative theta is equal to the secant squared of theta. So I'll say this is 1 minus the cosine squared theta over, for this guy, I'll just write secant squared theta. Okay, so now we're getting somewhere. Let me come down here just a little bit, and I'll put equals right here. Now, let's think about 1 minus cosine squared theta. If we go back and you look at this guy right here, again, sine squared theta plus cosine squared theta equals 1. Well, I could subtract cosine squared theta away from each side, and I would have sine squared theta is equal to 1 minus cosine squared theta. So in the place of 1 minus cosine squared theta, I can plug in a sine squared theta. So let's put sine squared theta, and then this is over. You have your secant squared theta. So secant squared theta. Now, what I'll do here is write secant squared theta as 1 over cosine squared theta. So we'll say that this is sine squared theta over 1 over cosine squared theta. So what is this going to give me? Well, I'll have my sine squared theta times the reciprocal of this. So this is going to be cosine squared theta like this. And so I'll just write this as sine squared theta and then cosine squared theta to finish it up. All right, let's take a look at the practice test. For the instructions, we're asked to verify each identity. And for the first problem, we see we have cotangent squared theta plus 1 is equal to secant squared theta times cotangent squared theta. Now for this particular problem, I'm going to consider this side over here on the left to be more simple, and I'm going to consider this side on the right here to be more complex. Again, you could change that up if you want. In order to have an easier time with these problems, you always want to think about what's the more complicated side, and you want to manipulate that side and leave the other side alone. In some cases, you have to mess with both sides, but in this case, we won't. So what I'm going to do for formatting is just put an equal sign here, and I'm just going to manipulate this right side here. And for this type of problem, I'm just going to write things in terms of sine and cosine. So for secant squared theta, this is 1 over, we would have our cosine squared theta. Then I'm multiplying by your cotangent squared theta. I can say that's cosine squared theta over sine squared theta. So if you don't know what to do, you can write things in terms of sine and cosine and just see what's going to cancel. So this right here would cancel with this right here. And now I have 1 over sine squared theta. Now, at this point, we don't have a match, right? We have cotangent squared theta plus 1. We have 1 over sine squared theta. But if you go to your identities handout, and again, you should always be thinking about the Pythagorean identities, we have this 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, what I have is this 1 over sine squared theta. Well, that is the same as cosecant squared theta. And cosecant squared theta is the same as 1 plus cotangent squared theta, or you could write it as cotangent squared theta plus 1, whatever you want to do. So I'll put this as cotangent squared theta plus 1, and we verified our identity. So I like to put a little check mark when I'm done, but of course that's not necessary. All right, let's take a look at the second problem. So here we have secant squared theta over sine squared theta, and this is going to be equal to 1 plus the cotangent squared theta over the cosine squared theta. So I'm going to consider, again, this guy on the left to be more simple and the guy on the right to be more complex. So let me format this way. I'll put equals here. And for 1 plus cotangent squared theta, we just saw in the last problem that can be replaced with cosecant squared theta. If you come down to, again, the Pythagorean identities, 1 plus cotangent squared theta is equal to cosecant squared theta. So let's go ahead and make that replacement. So I'll say this is cosecant squared theta over cosine squared theta. Now at this point, you don't have a match, so you think about what else you can do. I know that cosecant squared theta can be written as 1 over sine squared theta. So I can say that this is 1 over sine squared theta, and I'm going to multiply this by 1 over cosine squared theta. Now, if you look over here, you can see that you're getting somewhere because you have sine squared theta in the denominator here, and you have it here. But I need to get secant squared theta up here, and remember, 1 over cosine squared theta is the same as secant squared theta, and this is going to go off the screen, but we'll say that this is 1 over sine squared theta times, for this one, I'm going to say this is secant squared theta. And so now you have an exact match. So we can say that this is secant squared theta over sine squared theta. And again, I'm just going to put my little check mark here to show that I'm done. All right, for problem 3, we have 1 plus tangent squared x is equal to secant cubed x times cosine of x. All right, for this one, I'm going to leave, again, the guy on the left unchanged. Let me put this equals over here so I have enough room to work. If you see something like this, I would convert it and say that this is secant squared x times the secant of x times the cosine of x. Now, before you do anything with this, I want you to realize that secant of x times cosine of x, that's going to cancel and become 1. Let me write this out so that nobody's lost. So I'm going to put secant squared x again, and then times, for the secant of x, you could write that as 1 over the cosine of x, and then you have your cosine of x there. You could write that over 1 if you wanted to, and I'm just going to cancel this with this. So at the end of the day, you just have your secant squared x. Now, we have this 1 plus tangent squared x that we're trying to get a match on. Again, if you go back to your identities, tangent squared theta plus 1 equals secant squared theta. So we're basically good to go. We can just replace this and say it's tangent squared x plus 1 or 1 plus tangent squared x. So let's put 1 plus tangent squared x, and we have a match. So we'll put a check mark there, and we're done. All right, let's take a look at problem number 4. So here we have our cosecant squared x over cosine squared x. This is equal to secant squared x plus cosecant squared x. All right, so again, I'm going to consider this right side here to be more complicated. Let me scroll down here. You might want to write this down because this is definitely going to go off the screen. The first thing I'm going to do for this problem is write in terms of sine and cosine. So secant squared x, that's 1 over cosine squared x. Then plus for cosecant squared x, that's 1 over sine squared x. Now, when you get something like this, typically you would want to get a common denominator and combine these two. So let me slide this down just a little bit so I can fit that in. So I'm going to multiply this by sine squared x over sine squared x. And I'm going to multiply this by cosine squared x over cosine squared x. So what is this going to give me? In the numerator, you would have sine squared x plus your cosine squared x. And this is over the common denominator of cosine squared x times sine squared x. Now we know from the Pythagorean identities that sine squared x plus cosine squared x equals 1. So coming back here again, sine squared theta plus cosine squared theta equals 1. So let me come down here and say that this is going to be 1 over cosine squared x times sine squared x. Now, we are trying to get cosecant squared x over cosine squared x. That's pretty easy to do. I'm just going to break this up so it's more clear for you. This is 1 over cosine squared x times 1 over sine squared x. Now, 1 over sine squared x can be replaced with cosecant squared x. So basically, all we'd have to do to finish this up is say that this is 1 over cosine squared x times cosecant squared x. And then we'll say that this is cosecant squared x over cosine squared x. And I know we can't see it, it's off the page, but basically we verified our identity. All right, let's take a look at problem 5. So we have tangent squared theta plus 1 is equal to tangent of theta times secant of theta times cosecant of theta. All right, I'm going to leave this side again on the left unchanged. Let me write this equals all the way over here so I have some room. So I'm just going to write things in terms of sine and cosine. Let me put this down here. So for tangent of theta, that is sine of theta over cosine of theta. And then for secant of theta, that's 1 over cosine of theta. And then for cosecant of theta, that's 1 over sine of theta. So I know that this will cancel with this. And what I have here is 1 over cosine squared theta. Now, 1 over cosine squared theta can be replaced with the secant squared theta. And we know that secant squared theta is equal to tangent squared theta plus 1. Coming back to the Pythagorean identities, you have tangent squared theta plus 1 is equal to secant squared theta. So I'll just replace this with tangent squared theta plus 1, and I'll put a little check mark to show that I'm done. All right, for problem 6, we have cosecant squared theta minus 1 is equal to cosecant squared theta times cosine squared theta. So this one's really easy. I'm just going to leave the left side alone. So let me put this as equals here. And I'm going to think about cosecant squared theta as 1 over sine squared theta. And this is times cosine squared theta. So if you have cosine squared theta over sine squared theta, that's cotangent squared theta. So let's just write this as cotangent squared theta. And we know that we have this identity here. 1 plus cotangent squared theta is equal to cosecant squared theta. So let me write that out. So 1 plus cotangent squared theta is equal to cosecant squared theta. So if you're doing a problem like this and you have something that doesn't exactly match what you need, just write it out and see if you can manipulate it. So I want to end up with cosecant squared theta minus 1. So if I subtract 1 away from each side, then basically you'll see that I have something where I can replace cotangent squared theta with this cosecant squared theta minus 1, which is exactly what I need. So I'm just going to get rid of this and slide this down here like that for formatting and put equals here, and we're done. Right, so we show that this side, the cosecant squared theta minus 1, is the same as this side, cosecant squared theta minus 1. All right, for problem 7, we have cosine squared x is equal to cotangent of x over cotangent of x plus tangent of x. So for this one, I think it's crystal clear that the right side is more complicated. Let me put equals over here so I have some room. I'm just going to write in terms of sine and cosine and just see where that gets me. So the cotangent of x would be the cosine of x over the sine of x. And I'll put this over. Again, for the cotangent of x, that's the cosine of x over the sine of x. Then plus for the tangent of x, that's the sine of x over the cosine of x. Okay, this is going to get cut off, so you might want to note that this is cosine squared x that we're trying to match. So let's come down here. Let's think about this. And let me actually move this down here so the formatting looks a little bit cleaner. I would think about this as a complex fraction. And if you think about all the denominators, you have a denominator of the sine of x, and then the sine of x again, and the cosine of x. So the LCD there would be the cosine of x times the sine of x. So let's multiply the numerator of the complex fraction by the sine of x times the cosine of x, and the denominator of the complex fraction by the sine of x times the cosine of x. So this gets distributed here, and you can see that the sine of x's would cancel, and so what you would have is cosine squared x. Then this guy goes here, and you would have your sine of x cancel with your sine of x. So you have cosine of x times cosine of x, so that's cosine squared x. And then plus, this guy gets distributed here, the cosine of x's cancel, and now you have sine squared x. Now, this is interesting because we know that cosine squared x plus sine squared x is 1. So you can basically say this is cosine squared x over 1, which is just going to be cosine squared x, which is what we were looking for. So I'm just going to put a check mark there to show that I'm done. All right, let's take a look at problem number 8. So we have the sine of x over the cosecant of x. This is going to be equal to the tangent of x over the tangent of x plus the cotangent of x. All right, so just like in the last problem, what I'll do, I'm working on the right side here. I'm just going to write this in terms of sine and cosine and just see where that gets me. So I'll say that tangent of x is the sine of x over the cosine of x. Let me move this over here just a little bit for the formatting. So then the tangent of x, again, this is the sine of x over the cosine of x. And then the cotangent of x, that's going to be the cosine of x over the sine of x. Okay, so again, we have a complex fraction. So think about the LCD. You have cosine of x, and sine of x for the denominators. So the LCD there is the cosine of x times the sine of x. So I'll have cosine of x times the sine of x over the cosine of x times the sine of x. So I'm going to move this in here. And then basically the cosine of x's would cancel. So you get sine squared x over. Bring this in here. Cosine of x would cancel. You would have sine squared x, so sine squared x, and then plus, this is going to go here, and so sine of x would cancel. You would have cosine squared x. So just like in the last problem, we have the sine squared x plus cosine squared x. We know that's 1. So let's go ahead and say this is sine squared x. You could put over 1, you could just leave this. Now this isn't what we want. We want sine of x over cosecant of x. What you'd want is to break this up into the sine of x times the sine of x. Now we know that the sine of x is the same as 1 over the cosecant of x. So just take one of these and say this is 1 over the cosecant of x times the sine of x, and then we'll just write this as the sine of x over the cosecant of x, and we're done. All right, let's take a look at problem number 9. So here we have 1 over sine of theta is equal to sine of theta times your quantity cotangent squared theta plus 1. So for this one, it's very easy. I'm going to again work on the right side. Cotangent squared theta plus 1, I think you know at this point that that is cosecant squared theta. Again, going back, you can see that 1 plus cotangent squared theta is equal to cosecant squared theta. So I'll just say that this is the sine of theta times your cosecant squared theta. So I'm trying to match this here. It's going to be pretty easy to do. So I'm just going to say this is the sine of theta times, I'm just going to write this as 1 over sine squared theta. And essentially, this right here would cancel with one of these, right? You can even make this more clear by writing this as sine of theta times sine of theta like that, if it's a struggle for you to understand. You can cancel that, and now you just have your 1 over sine of theta that you're trying to match here. So let me put equals. I'll put 1 over sine of theta, and then I'll just go ahead and put a check mark to show that we're done. All right, let's take a look at problem 10. So here we have cotangent squared theta over 1 plus cosecant of theta is equal to 1 minus sine of theta over the sine of theta. All right, so for this one, I'm going to have the left side and the right side be equal to a common third expression. So I'm going to flip this for right now because in this particular case, as it stands right now, this side right here on the left is more complicated. And the way I like to format, I like what I'm manipulating on the right. So I'm just going to write this as 1 minus the sine of theta over the sine of theta. And this equals your cotangent squared theta over 1 plus cosecant of theta. Now, there's a lot of ways to attack this side right here. The simplest way I've found, if you come to your little handout and you think about the cotangent squared theta, well, that's the same as cosecant squared theta minus 1, right? So I'm just subtracting 1 away from each side there. So let me replace that with cosecant squared theta minus 1. Okay, so I'm replacing this with this. Let me put my equals here. So this is over 1 plus cosecant of theta. So you might ask why I did that. And basically, what's going to end up happening here, if you think about this, you have a squared minus b squared. So remember this formula. This factors into a plus b times a minus b. So if you factor this, you're going to be able to cancel here. So let's go ahead and get rid of this. So this would factor into your cosecant of theta plus 1, then times cosecant of theta minus 1. So let's put this over. You have 1 plus cosecant of theta. You could write that as cosecant of theta plus 1 if you wanted to. And I'm just going to cancel this with this. And now I have cosecant of theta minus 1. Let me come down here and just say that this is cosecant of theta minus 1. So at this point, I'm going to stop and I'm just going to copy this. I'm going to come to another sheet and I'm just going to put this in the middle. So let me put equals here and I'm going to write cotangent squared theta over 1 plus cosecant of theta. So what I'll do now is write 1 minus the sine of theta over your sine of theta. And then I'm going to flip this and write cosecant of theta minus 1 is equal to 1 minus the sine of theta over the sine of theta. So this won't be so bad to get this side to match this side now. So for this one, I'm going to split it up into 1 over the sine of theta minus the sine of theta over the sine of theta. And we know that 1 over the sine of theta is the cosecant of theta. So that's this part right here. And then minus sine of theta over sine of theta. Well, that's going to be 1. So now I have cosecant of theta minus 1 and cosecant of theta minus 1. So we're basically good to go there. So I'm just going to copy this part right here and come up here and paste this in, and I'll put equals over here. So this is one way that you could format it. There's different ways, but basically I'm showing that these two original guys that I started with are equal to this common third expression. So let me just put a check mark here to show that we're done. All right, let's take a look at the practice test. So for the instructions, we're asked to find the exact value. And for the first problem, we have the cosine of 17 pi over 12. Now, a lot of people do not like working with fractions. So what I would do if you're struggling with that is to convert this over to degree mode. It's not necessary, but I think I'm going to do it here because a lot of people will find this really, really hard. So I'm just going to say that this is 17 pi over 12. And I'm going to multiply this by 180 degrees over pi. And then I'm just going to cancel this pi with this pi. 180 divided by 12 is 15. And 15 times 17 is going to be 255. So this would be equal to 255 degrees. So now that it's in degree mode, you can easily break this up. I would just come to my unit circle and think about what's available. Well, you could do 120 degrees plus 135 degrees. So if we come back, you could say that this is the cosine of 255 degrees is equal to the cosine of 135 degrees plus 120 degrees. Now, the reason we're doing this is so that we can get an exact value. If you just punched in cosine of 255 degrees with your calculator, you're going to get an approximation. Sometimes you want an exact value. So you can use your sum identity for cosine to get that using these two angles here. Now, if your teacher gives it to you in radians, you probably want to show your steps in radians. So I'm just going to convert this over and say this is the cosine of, for 135 degrees, that is going to be 3 pi over 4 in terms of radians. Then plus for 120 degrees, that's going to be 2 pi over 3 in terms of radians. So let me get rid of this. And again, that step is not necessary. It's only if you're really struggling, and it would only do it for a limited period of time. Just try to get good at working with these fractions. So let's come down here and let's use our sum identity for cosine. So with this, remember, if you have the cosine of, let's say, a plus b, it's the cosine of a times the cosine of b. Then the sign is always different. So if this is a plus, now this is going to be a minus. So then you're going to have the sine of A times the sine of B. So it's the cosine of the first angle times the cosine of the second angle, then a different sign. So if this is a plus, this is a minus. If this had been a minus, so we're using the difference identity for cosine, then this would be a plus. Then you'd have the sine of the first guy times the sine of the second guy. So a real easy pattern to memorize. So it's just the cosine of the first guy, so 3 pi over 4. Times the cosine of the second guy, so 2 pi over 3. And then because this is a plus, we want a minus. Then the sine of the first guy, so 3 pi over 4. And then times the sine of the second guy, which is 2 pi over 3. Okay, let me get rid of this. And these are values that you can get from the unit circle. If you want to come up and pause the video and just look at this point right here and this point right here, this is what you're going to need. Let me just copy this. So this is negative 1/2, comma, square root of 3 over 2. So we know that the x-coordinate is the cosine value and the y-coordinate is the sine value. Okay, so that's for 2 pi over 3. So let me just reference that this is from 2 pi over 3. And then from 3 pi over 4, you have an x value or a cosine value. That's the negative of the square root of 2 over 2. And then you have a y value or a sine value. That's going to be the square root of 2 over 2. So this is something you should definitely memorize as soon as possible. It's just going to greatly speed up your work. All right, let's paste this in here. I'll just throw it to the side for right now. So I'm going to say this equals the cosine of 3 pi over 4. Again, that's the x-coordinate from this guy. So that's the negative of the square root of 2 over 2. And then times the cosine of 2 pi over 3. That's the x-coordinate here. So that's going to be negative 1/2. And then I'm going to go minus. Let me get rid of this part right here. We don't need that anymore. We just need the y values. So the sine of 3 pi over 4, again, I need this y value here. So this is the square root of 2 over 2. And let me get rid of this. And the last one is the sine of 2 pi over 3. So that's going to be square root of 3 over 2. Let me put times there and just move this up. Okay, so now it's pretty simple, just some arithmetic. We're going to say this is negative times negative, which is positive. Square root of 2 times 1 is just square root of 2. And this is over 2 times 2, which is 4. And then minus the square root of 2 times square root of 3 is the square root of 6. And this is over 2 times 2, which is 4. A lot of people would just write this with a common denominator. So this would be the square root of 2 minus the square root of 6. You can't really do anything with that. Then over the common denominator of 4. So the exact value here for the cosine of 17 pi over 12 is going to be the square root of 2 minus the square root of 6 over 4. Okay, let's take a look at problem 2. So now we have the cosine of negative 105 degrees. Now you could work with the coterminal angle. If you took negative 105 degrees and you added 360 degrees, you would get 255 degrees. Now you might stop and say, didn't we just do that? The answer is yes. We just found that answer. But we're going to do this in a different way. So I'm not going to use the coterminal angle. I'm going to use my negative angle identity that comes with cosine. So the cosine of negative theta is equal to the cosine of theta. So I can say this is equal to the cosine of 105 degrees. And you can stop and again, punch this into your calculator and this into your calculator. You'll see you get the exact same value. Now what you would do from here is just break this up. So I'm just going to do this in a different way. So let's go cosine of, let's go 150 degrees minus 45 degrees, just to change it up from what we just did. And 150 degrees minus 45 degrees is 105 degrees. So this is something we'll use the difference identity for cosine for. And again, we're expecting that same result, which is square root of 2 minus square root of 6 over that common denominator of 4. So let's see if we can get that. We're going to go cosine of the first guy, so of 150 degrees, times the cosine of the second guy, so 45 degrees. Remember, the sign is always different. So if this is a minus, this becomes a plus. Then you have the sine of the first guy, so 150 degrees, and then times the sine of the second guy, so 45 degrees. I think a lot of us know these values without going to the unit circle, but just in case you need it, we'll come up here. 150 degrees is going to be 5 pi over 6 in terms of radians. So we're looking at that point there. Let me get rid of these two previous points. And the other guy is 45 degrees, so that's going to be for this point right here. So again, let me write this as the negative of the square root of 3 over 2, and then 1/2. I'm just going to reference that came from this guy right here. So this is for the 150 degrees. And then for 45 degrees, let's say this is the square root of 2 over 2, and then the square root of 2 over 2. I think a lot of people know this one already. So let me get that there. Okay, so the first one is the cosine of 150 degrees. This is going to be the negative of the square root of 3 over 2. So the negative of the square root of 3 over 2, then times the cosine of 45 degrees is the square root of 2 over 2, then plus, for the sine of 150 degrees, that's going to be 1/2. So this is 1/2. And then the sine of 45 degrees is square root of 2 over 2. So times square root of 2 over 2. Let's make that a little bit better. So let's put equals there. So this right here would be the negative of the square root of 6, right? Square root of 3 times square root of 2 is square root of 6. And this is over 2 times 2 is 4. And then plus, you have 1 times square root of 2, which is square root of 2, over 2 times 2, which is 4. So it's the same thing, just in a different order. So you could say that this is the square root of 2 minus the square root of 6 over the common denominator of 4, like we just saw in the previous problem. All right, let's take a look at problem number 3 now. So here we have the cosine of 13 pi over 12. So again, if you're having trouble working with fractions and breaking it up, you can always convert this over to degrees. So let's just do that so that nobody's lost. So I'm going to take 13 pi over 12. I'm going to multiply this by 180 degrees over pi. And then the pi's are going to cancel. 180 divided by 12, that's going to be 15. And then 15 times 13, that's going to be 195. So this would be 195 degrees. If I had 150 degrees plus 45 degrees, well, that would get me to 195 degrees. So let me actually take everything now while I'm here so that we don't have to come back. And this is going to be 5 pi over 6. So let me just put 5 pi over 6. So that's 150 degrees in terms of radians. And I'm just going to notate that the x value here, the cosine value, so this is negative square root of 3 over 2. And the y value or the sine value is a half. So let me grab that. And then for pi over 4 or 45 degrees, let's write that here. I think everybody knows that's square root of 2 over 2 in each case, but let me write it out so that nobody is lost. And we're going to grab this, and let me come back and just paste this in here, throw it out of the way for right now. Let's get rid of this. I think maybe we don't have to write out our formula because we probably have memorized it by now. Let me slide down here a little bit. So this is the cosine of, again, I'm breaking this up into 5 pi over 6, which is 150 degrees, plus pi over 4, which is 45 degrees. Again, that would give me 195 degrees, or 13 pi over 12 in terms of radians. So this would be equal to, let me slide this over here, and I'll say the cosine of 5 pi over 6. And let me just take that value now so I can get rid of it. So this is negative square root of 3 over 2. And then times the cosine of pi over 4. So the cosine of pi over 4. So that's going to be this guy right here, which is the square root of 2 over 2. Let me get rid of this and this because we've used it. I'm just going to slide this down so I have room to work. And we'll go ahead and change colors here. So this is then going to be a minus because, again, this is a plus. So now I have the sine of 5 pi over 6. So that is going to be 1/2. So we know the sine of pi over 4 is going to be square root of 2 over 2. Let me get rid of this. I'm going to put the sine of pi over 4. Let's put equals, and let's put square root of 2 over 2. Pretty simple from here, just some basic arithmetic. So negative times positive is negative. Square root of 3 times square root of 2 is square root of 6. And this is over 2 times 2, which is 4. And then minus, we have 1 times square root of 2, which is the square root of 2, over 2 times 2, which is 4. So there's a lot of different ways that you could write this. I'm just going to keep it simple and say this is the negative of the square root of 6 minus the square root of 2 over 4. All right, for problem 4, we have the cosine of 285 degrees. So again, going to my unit circle, if I think about it, I could do 150 degrees, then plus 135 degrees. So let me write this out, 150 degrees. I'm going to grab these coordinates here. So the negative of the square root of 3 over 2, that's my cosine, and my sine is 1/2. And then for the other guy, which was 135 degrees, you know that has a 45 degree reference angle. So for the cosine value, it's the negative of the square root of 2 over 2, because again, we're negative in quadrant 2 for the cosine value, and the sine value is still positive, so that's just the square root of 2 over 2. So the negative of the square root of 2 over 2, and then this is the square root of 2 over 2. So let's grab this, and let me just paste this in here now, so we have it. So this equals, I'm going to say the cosine of 150 degrees plus 135 degrees. So this equals, I want you to just write this down. I'm going to get it out of the way. This is something that I've already memorized. And so hopefully you can memorize it very quickly because, like I keep saying, it's just going to greatly speed up your work on these problems. So I'm going to say this is the cosine of 150 degrees times the cosine of 135 degrees. Again, always change the sign. So this is a plus, so it becomes a minus. So now this is the sine of 150 degrees times the sine of 135 degrees. If you can't remember this from the unit circle, again, you can always think about things in terms of the reference angle. So 150 degrees has a 30 degree reference angle. So the cosine of 30 degrees is square root of 3 over 2, and we're in quadrant 2, so we know it's negative. So this is the negative of the square root of 3 over 2. Now, 135 degrees has a 45 degree reference angle. So if you wanted the cosine of 45 degrees, it's square root of 2 over 2. But again, this is negative because I'm in quadrant 2. So the negative of the square root of 2 over 2. Then minus. Now, sine in quadrant 2 is going to be positive. Right? So I can just think about the sine of 30 degrees, which is a half. and then the sine of 45 degrees, which is the square root of 2 over 2. So again, if you're having trouble with that unit circle, just go back to the concept of a reference angle. Sometimes it's a little bit easier. So let's come down here and put equals. So this is negative times negative, which is positive. Square root of 3 times square root of 2 is square root of 6 over 2 times 2, which is 4. And then minus 1 times square root of 2 is just the square root of 2 over 2 times 2, which is 4. So this would be the square root of 6 minus the square root of 2 over the common denominator of 4. All right, let's take a look at problem number 5 now. So here we see we have the cosine of 2 pi over 9 times the cosine of 4 pi over 9, then minus the sine of 2 pi over 9 times the sine of 4 pi over 9. So notice that this angle and this angle is the same. This angle and this angle is the same. And you have a minus here. So what does that tell me? Well, this is just basically us going in our normal formula for the cosine sum identity, but backwards. So in other words, normally you see cosine of, let's say, a plus b, and this is the cosine of a times the cosine of b, and then minus the sine of a times the sine of b. But because this is an equals here, I can go backwards, right? And I can put it in this form. So let's just do that real quick. We'll say that we have this being equal to the cosine of, take the first guy, so 2 pi over 9. And then again, this sign needs to be different, right? So this is a minus, it's going to be a plus. Then you're going to take the second guy, which is 4 pi over 9, right? So if you started with this, you know that you would expand it to this. So what I can do now is say this is equal to the cosine of, I have a common denominator of 9, so I can just go ahead and say, and this is a 4, it's just a poorly written 4. We can say that this is 2 pi plus 4 pi, which is going to be 6 pi, and this is over 9. Now I can reduce this fraction. 6 divided by 3 is 2, and 9 divided by 3 is 3. So this is going to be the cosine of 2 pi over 3. Now again, coming back to the unit circle, for 2 pi over 3, or 120 degrees, the cosine value is the x value from this point right here, so it's negative 1/2. So let's come back and just say this equals negative 1/2. Okay, let's take a look at problem 6. So here we have the cosine of 25 pi over 18 times the cosine of 5 pi over 9 plus the sine of 25 pi over 18 times the sine of 5 pi over 9. So again, this guy matches this guy matches this guy. Now you have a plus. So what you're going to do is say this equals, you're going to go cosine of the first angle, so 25 pi over 18. Because this is a plus, now you want a minus, and then you're going to take the second angle, so 5 pi over 9. So again, you're just going in reverse. So for this one, again, I have an 18 here and a 9 here. So let me just say this is times 2 over 2, so I can get a common denominator. So I'll say this is the cosine of 25 pi, and then minus 2 times 5 would be 10, so 10 pi, over the common denominator now would be 18. So we'll say this is equal to the cosine of 25 minus 10 is 15, so this would be 15 pi over 18. And we have a common factor of 3 between numerator and denominator. 15 divided by 3 is 5. 18 divided by 3 is 6. So this is the cosine of 5 pi over 6. So hopefully you know that's 150 degrees. And the cosine of 150 degrees, again, 30-degree reference angle. You're in quadrant 2. So it's going to be negative square root of 3 over 2. So this is the negative of the square root of 3 over 2. But again, you can always come back to your unit circle for 5 pi over 6. You're looking at that point there. Let me get rid of this one. And you want the x-coordinate, so negative square root of 3 over 2. All right, for the next few problems, we have new instructions. We want to find one value of theta. And coming down here for problem 7, we have the tangent of theta is equal to the cotangent of negative 40 degrees. So how can we solve this problem? Well, essentially what you're going to do is think about your cofunction identities. So remember that if you have the tangent of theta, this is equal to the cotangent of 90 degrees minus theta. Now, we used to say that theta had to be an acute angle back at the beginning of the course, but in this lesson that we just saw, we expanded the definition and theta can be anything as long as your function is defined, okay? So what we're going to do here is actually just replace the tangent of theta with this guy right here, the cotangent of 90 degrees minus theta. So that's all you have to do. So we're going to say this is the cotangent of 90 degrees minus theta, and this equals the cotangent of negative 40 degrees. Now, the reason this works is because you have cotangent over here and cotangent over here. So the only way that this can be equal is if this angle measure here is equal to this angle measure here. So what we'll do is say that 90 degrees minus theta is equal to negative 40 degrees. And what I'll actually do is add theta to both sides and add 40 degrees to both sides. And let's just go ahead and say that this would cancel and this would cancel. I'm just going to flip it around. I'm going to say theta is equal to 90 degrees plus 40 degrees is 130 degrees. All right, so this would be my solution. Now, when we get to solving trigonometric equations, we'll talk about how to write the full solution, which would include all of the possible solutions. Here, this is just one of an infinite number. Okay, for problem 8, now we have the secant of theta is equal to the cosecant of 1/2 times theta plus pi over 9. So for this one, we're going to use the same strategy as the last one. Now this is in terms of radians, so let me say that secant and cosecant are cofunctions. So the secant of theta is equal to the cosecant of, instead of 90 degrees, I'll just say pi over 2, because we're working with radians, minus whatever theta is. And let me make the parentheses a little bit bigger there. Okay, so I'm going to replace this with this, so I can set the angle measures equal. So I'm going to say the cosecant of pi over 2 minus theta is equal to, and I keep making that too short, so is equal to the cosecant of this, let's just go ahead and say 1/2 times theta plus pi over 9. So again, this can only be true if this is equal to this. So we'll say pi over 2 minus theta is equal to 1/2 times theta plus pi over 9. Now, I don't like working with fractions, so I'm just going to multiply both sides by the LCD. You have a denominator of 2, 2, and 9, so the LCD would be 18. So let me actually show this. So 18 times this side, and then 18 times this side. So 18 times pi over 2, 18 divided by 2 would be 9, so this is 9 pi. And then minus 18 times theta is just 18 theta. And this equals 18 times 1/2 is 9, so this is 9 theta. Then plus 18 divided by 9 is going to be 2. 2 times pi is 2 pi. So now we don't have any messy fractions, and so I'll just subtract 2 pi away from each side, and I'll add 18 theta to each side. And so this would cancel, and this would cancel. 9 pi minus 2 pi is going to give me 7 pi. And this equals 9 theta plus 18 theta is going to be 27 theta. Let me flip this around. I'm actually just going to write 27 theta is equal to 7 pi. I like what I'm solving for on the left, and I'll just drag this up here a little bit. I'm just going to divide both sides of the equation by 27. This cancels, and we're going to say that theta is equal to 7 pi over 27. So again, this is only one solution of an infinite number of solutions. So when we get to solving trigonometric equations, I'll show you how to get the full solution set. All right, for the next few problems, the instructions are going to change. Now we just want to verify each identity. And for problem 9, we have the cosine of theta minus 3 pi over 2 is equal to the negative of the sine of theta. So this one is really, really easy. I'm just going to flip this over here and put the negative of the sine of theta is equal to the cosine of this theta minus 3 pi over 2. This is just for formatting. I like what's changing to be on the right. If you want to do it a different way, that's up to you. So let's come down here, and I'm just going to put equals here. I'm going to use my difference identity for cosine. So this is cosine of theta. Let me slide this down. I don't think this is going to fit. And then times the cosine of 3 pi over 2. Then because this is a minus, I'm going to go plus. You want your sine of this theta here, and then times your sine of 3 pi over 2. So from here, it's pretty easy. Going back to the unit circle, so let me get rid of this. This is for 3 pi over 2. So remember, this is a 270 degree angle here. So the cosine value is your x value here, which is 0, and the sine value is the y value here, which is negative 1. So coming back, I'm going to take the cosine of 3 pi over 2, and I'm just going to plug in a 0. So this is cosine of theta times 0, which we know is 0. Then plus, for the sine of 3 pi over 2, I'm going to plug in a negative 1. So let's just put minus here. So minus, we'll say 1 times the sine of theta, like this. And of course, this is just going to go away. It's just 0. So you basically just have the negative of the sine of theta, which is what we had over there. So let me just put a check mark here to show we're done. Okay, for problem 10, this one's just as easy. So we have the secant of 3 pi over 2 minus x is equal to the negative of the cosecant of x. So let me flip this. So I'm going to put the negative of the cosecant of x is equal to, you have the secant of this 3 pi over 2 minus x. Now remember, if you're working with secant, it's the reciprocal of cosine. So what we can do right off the bat, let me move this all the way over here. I can just say this is 1 over the cosine of 3 pi over 2 minus x. So then let me put equals here. I'm just going to expand this. So let me put 1 over. We'll say this is the cosine of 3 pi over 2 times the cosine of x. And then this is a minus, so I want a plus. This is the sine of 3 pi over 2. Let me make this a little bit longer here. And then times the sine of x. Now, we know already that this guy right here is 0, right? So this is going to become 0. We know that this is negative 1, right? So this is going to become negative 1. So what you have here is 1 over, basically, the negative of sine of x. Now, we want the negative of cosecant of x, and we already have that. You could really break this up and say this is negative 1 times 1 over the sine of x. And 1 over the sine of x is the cosecant of x. So we can finish this up and say this is negative cosecant of x, which is what we wanted. All right, for the next few problems, the instructions tell us to find the cosine of s minus t. So here's problem 11. We're given the cosine of s is equal to negative 1/5. We're given that the sine of t is equal to 3/5. We're also told that s and t are both in quadrant 2. So let me come down here and say the cosine of s minus t is equal to the cosine of s and then times the cosine of t. And then because this is a minus, you want a plus. Now, whenever you put a plus next to a t, it's always confusing. So let me circle this so we know this is a plus. You have your sine of s times your sine of t. All right. So we are already given the cosine of s is negative 1/5 and the sine of t is 3/5. So the cosine of s, let me just say this is negative 1/5. And the sine of t is going to be 3/5. So how can we get the cosine of t and the sine of t? Well, some books will tell you to make a sketch, but you really don't need to do that. You can use your Pythagorean identity. I think it's a little bit quicker. So what you can do is say that cosine squared s plus sine squared s would be equal to 1. Now I know what the cosine of s is. It's negative 1/5, and I just want to square that. So let me get rid of this, and I'm going to put in negative 1/5, and I'm just going to square that. And let's come down, we'll come back up, and we'll say that negative 1/5 squared is going to be 1 over 25. And then we'll say plus sine squared s is equal to 1. Let's subtract 1 over 25 away from each side of our equation. This right here would cancel. Let me erase this so I can keep this in this frame here. I'm going to get rid of this and just move this up here. And then for 1, I would just write that as 25 over 25. So your sine squared s is equal to 25 minus 1 is 24, and this is over 25. Now we're going to use our square root property to find the sine of s, but remember it told us we were in quadrant 2. Sine is positive in quadrant 2, so you want the principal square root here. So you want to say the sine of s is equal to the principal square root of 24 over 25. And if you think about that, you can break it up. So let's say this is the square root. For 24, let's write that as 4 times 6 over the square root of 25. So for this, the square root of 4 is 2. The square root of 6, you really can't do anything with that. So this is 2 times square root of 6 over the square root of 25 is 5. So let me get rid of this, move this up here. So I'm just going to plug in for the sine of s, 2 times square root of 6 over 5. Okay, so this is multiplied, and then this is a plus sign here. Let me go ahead and circle this so nobody is confused. And let me slide this down just a little bit so the other guy fits in there. Okay, so this is going to be multiplied. So for the cosine of t, again, let's use sine squared t plus cosine squared t equals 1. I'm just going to write that a little bit differently. I'll say this is cosine squared t is equal to 1 minus sine squared t. And I'll plug in for the sine of t, it's 3/5. So let's write cosine squared t is equal to 1 minus, plug in a 3/5, and this is going to be squared. So 3/5 squared would be 9 over 25. And we can just speed this up a little bit. This would be 25 over 25. And we'll say that 25 minus 9 is 16, so this is 16 over 25. Now, we said that we were in quadrant 2. In quadrant 2, cosine is negative. So I'm going to say that the cosine of t is equal to the negative square root of 16 over 25, which would be equal to negative, the square root of 16 is 4, and then the square root of 25 is 5. So this right here, the cosine of t is negative 4/5. Let me get rid of this. I'm just going to put equals here and then just use these values. So negative 1/5 times negative 4/5, negative times negative is positive. So this is 4 over 5 times 5 is 25. Then plus, you have 2 times square root of 6 times 3. That's just going to be 6 times square root of 6 over 5 times 5 is 25. So you have a common denominator here. You can just say that this is 4 plus 6 times square root of 6 over 25. All right, let's take a look at problem 12 now. So we have the sine of s is equal to the square root of 5 over 7, and the sine of t is equal to the square root of 6 over 8. So s and t are in quadrant 1 now, so we know everything is positive. So coming down here again, we want the cosine of s minus t. So this is, again, the cosine of s times the cosine of t. And let me put the plus sign here and circle it so nobody's confused. This is a t and this is a plus sign. So now we would have the sine of s times the sine of t. Now we're given the sine of s and the sine of t. If we come back, the sine of s is the square root of 5 over 7. So this is the square root of 5 over 7. And the sine of t is the square root of 6 over 8. So this is the square root of 6 over 8. All right, let me put my plus sign here and circle it. And then what we want to do is think about the cosine of s and the cosine of t. Again, you can just use the Pythagorean identity. You could also make a sketch if you want. It's really up to you. So for the cosine of s, let's say that cosine squared s is equal to 1 minus sine squared s. And we know that the sine of s is square root of 5 over 7. So this is the square root of 5 over 7. So we're going to square that. So that would be 5 over 49. So this is 5 over 49. And I'm going to write this as 49 over 49. 49 minus 5, that's going to be 44. So this is 44 over 49. Now again, we're in quadrant 1, so everything's positive. So the cosine of s is the principal square root of 44 over 49, which is the square root of 44. Let's write that as 4 times 11 over the square root of 49. So square root of 4 is 2. So this is 2 times square root of 11 over square root of 49 is 7. So this right here for the cosine of s, this is 2 times square root of 11 over 7. Okay, so for cosine of t, we're going to use something very similar. We're going to say that the cosine squared t is equal to 1 minus sine squared t. Now the sine of t is square root of 6 over 8. So we want to plug in the square root of 6 over 8, and we want to square that. So this is 6 over 64. So 6 over 64. You can write this as 64 over 64. And 64 minus 6, that's going to be 58. So this is 58 over 64. Okay, so the cosine of t is equal to, let's say the principal square root, because again, we're in quadrant 1, of 58 over 64. So this equals, let me slide down here a little bit. We'll say the square root of 58 over the square root of 64. So the square root of 64 is 8. Now what about the square root of 58? Well, 58 is 29 times 2. 29 is a prime number, and also 2 is a prime number. So we really can't do anything else with this. This is just the square root of 58. So let me get rid of this, and let me drag this up here, and arrow to this, and put a multiplication symbol in there. And I'll just put equals here, and we'll use these values. So for this first guy here, you could cancel a factor of 2 between numerator and denominator, but I don't think you want to do that, because here you have 7 times 8, which is 56, and here you have 7 times 8, which is 56. So it's better to not do that so we have a common denominator, because we're going to be adding. So let's go ahead and say this is 2, let me slide this down here a little bit so it's a little bit better formatted, times square root of 11 times square root of 58. Now really you can't do anything with that, because 11 times 2 times 29, there's really nothing else you can do other than to say this is the square root of 11 times 58, which is 638, over 7 times 8 is 56. So then plus, over here, square root of 5 times square root of 6, that's square root of 30, over 7 times 8, again, is 56. Can you do anything here? No, you can't. This is going to be as simple as you can make this. You can write it with a common denominator and just say this is 2 times square root of 638 plus the square root of 30 over the common denominator of 56. All right, let's take a look at the practice test. For the instructions, we're asked to derive the given identities. And for problem 1, we're going to start with the sine of a plus b. In the previous lesson, we talked about how we could get something like the cosine of, let's say, a minus b. And we also know how to do the cosine of a plus b, but we're going to use this one here. So this is what? It's the cosine of a times the cosine of b. And then your sign is always different. So if this is a minus, this is a plus, and then it's the sine of a times the sine of b. Real easy formula to remember. Additionally, we need our cofunction identities. We talked about this earlier in the course, and we also updated this in the last lesson where we said that the sine of some angle a is equal to the cosine of 90 degrees minus that angle a, and then also the cosine of some angle a is equal to the sine of 90 degrees minus that angle a. So if you have the sine of a, you can replace it with the cosine of 90 degrees minus a. Or you could go in reverse. If you had the cosine of 90 degrees minus a, you could replace that with sine of a, and you could do the same thing with this guy. So let's come up here, and the first thing I'm going to do is replace the sine of a plus b with the cosine of 90 degrees minus this angle here. So I'm going to put inside of parentheses a plus b like this. Okay, let me put equals here, and I'll just go down this side. What I'm going to do is actually distribute this negative to each guy inside. So in other words, I'm going to have cosine of 90 degrees, then minus a, and then minus b. So now I'm going to actually group these guys together, and I'm going to say that this is the cosine of 90 degrees minus a. So let me wrap that in some parentheses, and then minus b. So we're going to treat this guy as an angle and this guy as an angle. So we're going to use that cosine difference identity. So let's come down here a little bit more, and let's say this equals the cosine of the first guy. So the first angle is 90 degrees minus a. Then I'm going to go times the cosine of the second guy. So this is just b here. Then if this is a minus, you want a plus here. So now I'm going to go with the sine of the first guy, which is 90 degrees minus a, and then times the sine of the second guy, which is b. Now, from here, I want you to remember, if you have the cosine of 90 degrees minus a, you can replace that with the sine of a. So I'm just going to say that this part right here is going to be the sine of a. That's from our cofunction identities. Then you have times the cosine of b, and then you have plus, again, right here. If you have the sine of 90 degrees minus a, you can replace that with the cosine of a. So let's say this is the cosine of a, and then times the sine of b. So that's how we get our formula that we talked about in the lesson. Pretty easy to do overall. All right, let's take a look at problem 2. So for this one, I'm going to rely on what we already did in problem 1. So now we have the sine of a minus b. So in problem 1, we used a bunch of different identities to determine that the sine of a plus b was equal to the sine of a multiplied by the cosine of b. Then we had plus our cosine of a times our sine of b. Now, what I would do here is just write this in such a way that I can use this guy, and then we can use our negative angle identities to get the full formula. So I'll go ahead and say that this is the sine of a plus negative b, like this. And so just using this formula here, we'll say this is the sine of a times the cosine of negative b, and then we have plus our cosine of a times our sine of negative b. Now, using the negative angle identities, remember the cosine of negative b is the same thing as the cosine of b. So I can just say that this is the sine of a and then times the cosine of b. Now, when we get to this part right here, the sine of negative b is the same thing as the negative of the sine of b. So that's going to change this sign from a plus to a minus. So now you have a minus cosine of a times sine of b. So this part matches this part, and this part matches this part. The only change is in the sign, right? This is a plus and this is a minus. So you just have to remember, if you have the sine of a minus b, this is a minus, right? So the same signs. Then if you have the sine of a plus b, you have a plus here, right? So it's always going to be the same signs. If this is a plus, this is a plus. If this is a minus, this is a minus. All right, let's take a look at problem 3. So here we have the tangent of a plus b. So how do we derive our formula? Well, the first thing is I want you to recall that tangent is sine over cosine. So just put this in terms of sine and cosine first. So we'll say this is the sine of this angle A plus B over your cosine of this angle A plus B. So that's the first step. Now, we know how to use the sum identity for sine and the sum identity for cosine. So I'm going to say that this is the sine of A times the cosine of B. And then I'm going to say that this is plus, this will be the cosine of A times the sine of B. Now this is going to be over. Down here, you would have the cosine of A times the cosine of B, and then minus your sine of A times your sine of B. So let me actually copy this, and I'm just going to paste this in here. And I'm going to put equals here, and I'm going to multiply by 1 over cosine of A times cosine of B, and then over 1 over cosine of A times cosine of B. So this is just a complicated form of 1, right? Multiplying things by 1 does not change anything. The idea is that this is going to get distributed to this, and then this will be distributed to this and this. And we're going to see a lot of stuff cancel. So let's come down here and see what that looks like. So this is going to go here and here. So let me write this as the sine of A times the cosine of B over this denominator here, which would be the cosine of A times the cosine of B. Then we have a plus here, so let me put plus. You're going to have your cosine of A times your sine of B over, again, you're going to use the cosine of A times the cosine of B. So that's this part right here. Now I got to do the same thing down here. So this times this, and then minus this times this. So let me come over here and put a fraction bar here. I'll just scooch down a little bit. And so this guy right here would be the cosine of A times the cosine of B over your cosine of A times your cosine of B. And then you have a minus here. So let me put minus. You're going to have your sine of A. So your sine of A times your sine of B over your cosine of A times your cosine of B. All right, so far, so good. It's not too bad. Let me put equals here. And we're going to see a lot of stuff cancel. So cosine of B over cosine of B, that is 1. Cosine of A over cosine of A, that is 1. This guy right here is going to cancel completely to 1 because you have cosine of A times cosine of B over cosine of A times cosine of B. So that is just a big fat 1. Let me actually put a 1 here and a 1 here so that nobody is lost. And then here, nothing's going to really cancel. Now, if I look at what's left, I have sine of A over cosine of A. Remember, that's the tangent of A. So I can say that this is the tangent of A, and then plus the sine of B over the cosine of B is just the tangent of B. And this is over. Remember, this canceled and became a 1. Okay, a lot of people make the mistake of not writing this and just putting the negative of whatever we get here. But remember, this is a 1, and you have 1 minus whatever this is. So make sure you put the 1 there and the minus. And let me actually break this part up to make it more clear. So the sine of A over the cosine of A times the sine of B over the cosine of B. So the sine of A over the cosine of A would be the tangent of A, and then the sine of B over the cosine of B would be the tangent of B. So that's where the formula comes from. And if you want the other one, we're going to derive it in the next problem. All right, for problem 4, we're going to look at deriving the tangent of A minus B formula. So we just found that the tangent of A plus B was equal to, we had the tangent of A plus the tangent of B over 1 minus the product of these two. So we would say the tangent of A times the tangent of B. All you need to do is take and write this as A plus negative B, plug into the formula, and you're just going to see that this sign is going to change and this sign is going to change. That's all it's really going to do. So we're going to say this is equal to the tangent of A plus negative B, like this. So this is, again, just following this formula, the tangent of A plus, you have the tangent of B. In this case, you have a negative B there. So if I have the tangent of negative B, and I'll just do this now so we can go a little bit quicker. Remember, the tangent of negative B is the same as the negative of the tangent of B. right? Tangent is an odd function. So you can put a minus here and get rid of this. And so we'll slide this part down here. So you can see there's a sign change here from here. So then this is over 1 minus the tangent of A, so the tangent of A, and then times, in this case, it would be the tangent of negative B. So here's where you get another sign change. Because this is the tangent of negative B, again, you can use your negative angle identities and say this is the negative of the tangent of B. So just pull that negative out. So this would now be a plus. So our formula becomes the tangent of A minus the tangent of B over 1 plus the tangent of A times the tangent of B. All right, for the next few problems, we're asked for the instructions to find the exact value. And for problem 5, we're given the sine of 5 pi over 12. So again, if you're working with radians and it's difficult for you to break things up, just convert it over to degrees and then convert it back over. So if you have 5 pi over 12, and you multiply this by 180 degrees over pi, this is going to cancel with this. 180 divided by 12, that's going to be 15, and 15 times 5 is 75, so this is 75 degrees. So you could break this up using two angles from the unit circle, so something like 45 degrees and 30 degrees, and with 45 degrees, it's pi over 4 in terms of radians, and with 30 degrees, it's pi over 6. So you could say that this is the sine of pi over 4, so remember that is 45 degrees in terms of radians, then plus pi over 6, this is 30 degrees in terms of radians, so close that down. Let's get rid of this, and some of you don't need to do that, some of you do. It's just an extra step if you need it. So let's come down here, we'll just say this equals, again, I'm just going to use my sum identity for sine, so I'm going to say this is the sine of pi over 4, and then multiplied by the cosine of pi over 6, then plus, we have the cosine of pi over 4, and then times the sine of pi over 6. Now, hopefully at this point, you don't need the unit circle. You have one that I've provided to you if you need that. I'm just going to go off memory here. And the sine of pi over 4, again, for the sine of 45 degrees and the cosine of 45 degrees, it's always going to be square root of 2 over 2, right? It's the same thing. So this right here is going to be the square root of 2 over 2. And this right here is going to be the square root of 2 over 2. This is the easiest one to remember. Let me put my plus here. Now the cosine of pi over 6, again, if you're thinking about 30 degrees, that's square root of 3 over 2. So this is square root of 3 over 2. And then the sine of pi over 6, that's going to be 1/2. Okay, so let's just go through and do our calculations now. So square root of 2 times square root of 3 is the square root of 6. This is over 2 times 2, which is 4. Then plus square root of 2 times 1 is the square root of 2. This is over 2 times 2, which is 4. So this gives me the square root of 6 plus the square root of 2 over the common denominator of 4. All right, for problem 6, we want to find the tangent of 255 degrees. So this would be the tangent of, let's go ahead and say 135 degrees plus 120 degrees. So this would be tangent of the first guy, so 135 degrees, then plus the tangent of the second guy, so 120 degrees. This is over 1 minus, so again, this sign right here is going to match this sign, and it's going to be different from this sign. So that's how I remember it. So you're going to multiply the tangent of the 135 degrees times the tangent of 120 degrees. So just something you have to write down a few times. So let's say this equals, and before we can continue, I need to find the tangent of 120 degrees and the tangent of 135 degrees. And again, with the tangent, it's not on the unit circle, right? So you need the sine divided by the cosine. So you can go to the unit circle and get the sine value, the cosine value, do your division, and you'll have your tangent. So for the tangent of 120 degrees, this is the sine of 120 degrees divided by the cosine of 120 degrees. Again, hopefully you know these guys off the top of your head at this point. The sine of 120 degrees, again, I'm in quadrant 2, so sine is positive, and you have a 60-degree reference angle. So this is the square root of 3 over 2. And then for the cosine of 120 degrees, you're negative in quadrant 2, 60-degree reference angle. Your cosine of 60 degrees is a half, so this would be negative 1/2. So here I would just say this is square root of 3 over 2 times the reciprocal of this, so negative 2 over 1. So this would cancel, and so you'd have the negative of the square root of 3. Okay, for the tangent of 135 degrees, it's really, really simple. You have a 45-degree reference angle. You know that the sine of 45 degrees and the cosine of 45 degrees, in each case, is square root of 2 over 2. But the cosine is negative in quadrant 2. So you have to think about this as, let me go the sine of 135 degrees over the cosine of 135 degrees, which is square root of 2 over 2. And then for this one down here, it's the negative of the square root of 2 over 2. So this just becomes negative 1. Okay, so the tangent of 135 degrees is going to be negative 1. We put that there. And so if I grab these two, and let me just paste this in here, I'm just going to replace the tangent of 135 degrees with a negative 1. So let's put negative 1 there. Then for the tangent of 120 degrees, let's just erase that and put negative square root of 3 there and make that a little bit better. So here, the tangent of 135 degrees, that's going to be, again, negative 1. Let me wrap this so we don't make a sign mistake. And then times the tangent of 120 degrees, that's going to be negative square root of 3. So first and foremost, you have negative 1 minus square root of 3. Can you do anything with that? At this point, no. So I'm just going to write negative 1 minus the square root of 3. Then this is over. You have negative 1 times negative square root of 3, which is going to be the square root of 3. So this is 1 minus the square root of 3. So this is where a lot of people get stuck. Let me actually grab this. All right, so I'm just coming to a new page so we can have a lot of room to work. You don't want a radical in the denominator. So what you would do in this situation, because it's two terms, you would multiply by 1 plus the square root of 3 over 1 plus the square root of 3. So remember, 1 plus the square root of 3 and 1 minus the square root of 3, those are conjugates. So we use that formula where you have, let's say, a plus b times a minus b. This is a squared minus b squared. So we're just going to use that formula. So here, let's just do the numerator first. Now, here you can't use the formula because this is not the same as the a plus b times a minus b. So you would have to FOIL this out. So negative 1 times 1 is negative 1. And then you would have negative 1 times square root of 3, which is minus the square root of 3. And then you would have the negative of the square root of 3 times 1, which is minus the square root of 3. And then you have a negative square root of 3 times square root of 3, which is minus 3. Negative 2 times square root of 3. So negative 2 times square root of 3. And of course, negative 1 minus 3 would be negative 4. So let's just write negative 4 minus 2 times square root of 3. Let's put this over. Here I'm going to use my formula. So just square the first guy. 1 squared is 1. Then minus square the last guy. Square root of 3 squared is 3. So 1 minus 3 is going to be negative 2. Let's just do that right now. And from here, we can do a little bit of simplifying. I could factor out a negative 2 from the numerator. And so I could say that this is negative 2 times the quantity 2 plus the square root of 3 over this negative 2. I'll cancel this common factor of negative 2 between numerator and denominator. And I'm left with my answer, which is 2 plus the square root of 3. All right, let's take a look at problem 7. So here we have the sine of 47 pi over 18 times the cosine of 10 pi over 9 minus the cosine of 47 pi over 18 times the sine of 10 pi over 9. So realize that this is just your difference identity for sine in reverse. So let's say this is equal to the sine of, I'm going to take the first angle, so 47 pi over 18, then minus the second angle, so 10 pi over 9. If you go through your formula, you're going to end up with this, right? So I'm just going in reverse. So if you get this type of problem, usually you're just meant to combine what's inside the parentheses and then take the sine of that. So this would be the sine of, for this I would need a common denominator. So let's say 47 pi over 18, then minus 10 pi over 9 times 2 over 2. That way I have a common denominator of 18. So this would be the sine of 47 pi minus 10 times 2 is 20. So this would be 20 pi over the common denominator of 18, right? So you have 18 here and 9 times 2 is 18. So this would be the sine of 47 minus 20 is 27. So this is 27 pi over 18. And of course, each here is divisible by 9. 27 divided by 9 is 3. 18 divided by 9 is 2. So this is the sine of 3 pi over 2, or you could say the sine of 270 degrees if that's easier to remember. And this is going to be negative 1. Okay, let's take a look at problem number 8. So here we have the tangent of pi over 18 plus the tangent of 5 pi over 18. This is over 1 minus the tangent of pi over 18 times the tangent of 5 pi over 18. Okay, coming down here, this is just me going again in reverse. So you have a plus here and a minus here. So that tells me I want tangent of this first guy, which is pi over 18, and then plus. So this sign matches this sign. You have this other angle here, which is 5 pi over 18. Okay, so I already have a common denominator, so I'll just say this is the tangent of 5 pi plus pi is going to be 6 pi. So this is 6 pi over your common denominator of 18. So between 6 and 18, you have a common factor of 6. So 18 divided by 6 would be 3. Of course, 6 divided by 6 is 1. So this would be the tangent of pi over 3. Now let's think about that for a moment. Pi over 3 is 60 degrees. So what is the tangent of 60 degrees? So the sine of pi over 3, or 60 degrees, is square root of 3 over 2. And the cosine of pi over 3, or again 60 degrees, is 1/2. So for the tangent, you want the sine divided by the cosine. So you would take square root of 3 over 2, and you would multiply by the reciprocal of 1/2. So you'd multiply it by 2 over 1, or just 2. And essentially, your 2's are going to cancel here, and you just have the square root of 3. So this is just going to be the square root of 3. Let me make that 3 a little bit better. All right, for the next few problems, we're just asked for the instructions to simplify. And for problem 9, we have the sine of negative 4v times the cosine of 5v plus the cosine of negative 4v times the sine of 5v. So again, we have a similar problem to the previous two, but it's a little bit different because we're just going to simplify here. So let me put equals. I'm just going to say this is the sine of the first guy, which is negative 4v. And then because this is a plus here, I'm going to go ahead and say this is a plus here because, again, we're working with the sine sum identity. And then I would take the 5v, the second angle that appears. Again, you can always just reverse this. If you had the sine of negative 4v plus 5v, you could set it up this way using your sine sum identity. So all you'd really have to do here is just say negative 4v plus 5v is v. So this becomes the sine of v. All right, let's take a look at problem 10. So here we have the tangent of theta minus the tangent of 4 theta over 1 plus the tangent of theta times the tangent of 4 theta. So again, using my formula, just think about the fact that this is a minus, okay? So if you're working with tangent and you have your sum or difference identity, then this guy right here needs to match what's inside there. So you'd have the tangent of the first guy, which is theta. This needs to match, so this is a minus. And then this guy right here, the second angle, so 4 theta. So this would just be the tangent of negative 3 theta. And again, using your negative angle identities, you could say this is the negative of the tangent of 3 theta. And you don't have to put parentheses there. I'll just say this is the negative of the tangent of 3 theta. All right, for the next few problems, we want to find the sine of theta plus beta, the tangent of theta plus beta, and the quadrant of theta plus beta. Now for problem 11, we are given theta and beta, not theta plus beta, but theta and beta individually. They're both going to be in quadrant 1. We're told that the cosine of theta is 3/5 and the sine of beta is 5 over 13. Let me write this down. So the cosine of theta is equal to 3/5 and the sine of beta is equal to 5 over 13. So basically, you need to get a lot of different pieces of information for this type of problem and then put it all together. Now, what I would say is that after you work enough of these problems, you start to recognize that, hey, if I have the cosine of theta is equal to 3/5, well, given the fact that I have a 3, 4, 5 right triangle, well, then the sine of theta, again, theta is in quadrant 1, would be 4/5. You could do this the slow way if you want, but for these problems, they're so time consuming. If they give you a little shortcut like that, you need to take it. So let me prove this to you real quick. So sine squared theta, we know is 1 minus cosine squared theta. So for the cosine of theta, it's 3/5, and you want to square that. So 3/5 squared would be 9 over 25. And I would write this as 25 over 25. 25 minus 9 is 16, so this is 16 over 25. And again, I would want the principal square root here because I'm in quadrant 1. So this is sine of theta is equal to 4 over 5. So again, this is the long way. If you need to do it this way, that's fine. But after you do enough of these problems, if you see the cosine of theta is 3/5 and I'm in quadrant 1, I immediately know the sine of theta is 4/5, right? 3, 4, 5 right triangle. Then this other one is going to be similar. If you think about your Pythagorean triples, you also have something called a 5, 12, 13 right triangle. So for this guy, you could say that the cosine of beta is equal to what? Well, now it would be 12 over 13, right? So 5, 12, and then you have your 13, okay? Remember, this is your y, this is your r, this is your x, this is your r. So another way you can think about that is 5 squared plus 12 squared would be equal to 13 squared. Your y value squared plus your x value squared would give you your r value squared. And you can crank that out. That would be 25 plus 144 is equal to 169, which is a true statement. Again, another way to do this would be that cosine squared beta is equal to 1 minus your sine squared beta. So 5 squared is 25. 13 squared is 169. And so this would be 169 over 169. Let me make this a little bit better. My handwriting's getting a little sloppy there. So 169 minus 25 is 144. So this would be 144 over 169. And again, we're in quadrant 1. So the cosine of beta is equal to the principal square root of 144 over 169, which is the square root of 144 is 12, and the square root of 169 is 13. So again, you get your 12 over 13. So however you want to do it, but again, you're meant to take some shortcuts on problems like these. Now, we also want to get the tangent of theta, and we want to get the tangent of beta. Okay, so for this one, it's going to be sine divided by cosine. So it's 4/5 times the reciprocal of 3/5, which is 5/3. So this is going to be the 5s are going to cancel, you get 4/3. So this is 4/3. Okay, for this one, the tangent of beta, you're going to have 5 over 13 times the reciprocal of 12 over 13, which is 13 over 12. This cancels, so you get 5 over 12. Okay, so 5 over 12. Okay, so now we pretty much have everything that we need. Let's start off with the sine of theta plus beta. So the sine of theta plus beta. Again, use your formula. So it's the sine of theta, then times the cosine of beta. Then you have plus your cosine of theta times your sine of beta. Let's paste these in here so we don't have to try to remember. So the sine of theta was 4/5. Let's plug that in there. The cosine of beta was 12 over 13. Let's plug that in there. The cosine of theta is 3/5. Plug that in there. And then the sine of beta is going to be 5 over 13. Okay, so that's basically all you need. And at this point, it's just a calculation, right? So 4 times 12 is going to be 48. This is over 5 times 13 is 65. And then plus 3 times 5 is 15. And this is over 5 times 13, which is 65. And the reason I didn't cancel there is because I want to get a common denominator. If you go through and cancel stuff, a lot of times with these problems, you have to go back and get a common denominator. And it's just extra work. So now I can do 48 plus 15, and that's going to be 63. And this is over the common denominator of 65. So that's my sine of theta plus beta. So let me write that there. That's one thing that we needed. We also wanted the tangent of theta plus beta. So let me actually go to a different page here, and I'm going to work that out, and I'll come back up and answer it there. So this is what? This is the tangent of, let me actually write this down here so I have more room. So this is the tangent of theta, and then plus the tangent of beta over 1 minus the tangent of theta times the tangent of beta. Okay, let me slide this up a little bit. And I forgot my 1 there. And let's just paste this in here real quick. So the tangent of theta, I'm just going to erase this and put in a 4/3. The tangent of beta is 5/12. Let's put that in there. And then again, for the tangent of theta, you have 4/3. For the tangent of beta, you have 5/12. Now, these problems are never fun to simplify. Now, because this is a complex fraction, what you could do is think about all the denominators involved. Let me write this as 20 over 36, so I don't have to do double work here. And so the LCD would be 36, right? You have 36, 12, and 3. So you could multiply this by 36 over 36, and you would clear all those denominators. Again, this is one strategy of many that you could use. So this would come to there and there. So 36 divided by 3 is 12. 12 times 4 is 48. Then plus 36 divided by 12 is 3. 3 times 5 is 15. This is over. This would go here and then here. So 1 times 36 is 36, and then minus 36 divided by 36 is 1. So this is just 20. So this is going to give me, let me actually slide this over just a little bit, 48 plus 15. We just did that. We know that's 63. And this is over 36 minus 20. That's going to be 16. So this would be my tangent of theta plus beta. So let me copy this. So those are the first 2 answers. You're also told to find what quadrant is theta plus beta in. So you have the sine of theta plus beta, that's positive. You have the tangent of theta plus beta, that's positive. Again, just think about your all students take calculus. So let me draw this out here. All students take calculus. So everything is positive in quadrant 1. In quadrant 2, it's sine and cosecant. In quadrant 3, it's tangent and cotangent, and in quadrant 4, it's cosine and secant. So if I think about it, the overlap here, they're both positive. They're going to have to be in quadrant 1, right? Because sine is positive in quadrants 1 and 2, but in quadrant 2, tangent would be negative, right? So you have to be in quadrant 1. So let's just go ahead and get rid of this and just say that theta plus beta is in quadrant 1. All right, let's take a look at problem number 12. So we have theta and beta in quadrant 3. We're given that the cosine of theta is negative 8 over 17, and then the cosine of beta is negative 3/5. Although the problem is very tedious, we have two easy scenarios because this, you can think about an 8, 15, 17 right triangle, and this one a 3, 4, 5. So again, let me come down here and just say that the sine of theta would be what? Again, if this is 8 and this is 17, forget about the fact that it's negative, you would have 15 and 17. Think about your quadrant. You're in quadrant 3, so sine is negative, so this is negative 15 over 17. Then for this one, for the sine of beta, again, if I'm in quadrant 3, sine is negative, and again, you have 3 and 5, so you want 4 over 5, right? Again, 3, 4, 5 right triangle, 8, 15, 17 right triangle. That's where I'm getting that from. Now, again, if that's confusing for you, you can always do this the long way. It's not a big deal. So if you want the sine of theta, you can say sine squared theta is equal to, you have 1 minus your cosine squared theta. So this would be negative 8 over 17 squared. So this would be 64 over 289. So 64 over 289. And you would say that this is 289 over 289. And so 289 minus 64, that's 225. So this right here would be 225 over 289. Now, because we're in quadrant 3, you want the negative square root. So you would say the sine of theta is equal to the negative of the square root of 225 over 289, which would be negative 15 over 17. So negative 15 over 17. So again, if you don't get the shortcut or you don't realize it right away, you can just do it the long way. It's not that big of a deal. Then for the other one, again, if I have sine squared beta, this equals 1 minus cosine squared beta. So this would be me plugging in negative 3/5 and squaring it. So this would be 9 over 25. I think we've done this a million times at this point. So this is going to be 25 over 25. And so this would end up being 16 over 25. And again, I am in quadrant 3. So I want the negative square root. So the sine of beta is equal to the negative of the square root of 16 over 25, which equals negative square root of 16 is 4, square root of 25 is 5. So that's how I got the negative 4/5 for sine of beta. Okay, so now that we have that information, let's figure out our tangent. So we need the tangent of theta. That equals what? Well, we would take the sine of theta, which is negative 15 over 17, and we'd multiply by the reciprocal of the cosine of theta, which is negative 17 over 8. So this would cancel. This is 15 over 8. And then for your tangent of beta, this is equal to what? Again, take your sine of beta, so negative 4/5, and multiply by the reciprocal of the cosine of beta, which would be negative 5 over 3. And so in this case, this would cancel, and you get negative 4 over negative 3, which is going to be 4/3. So this is 4/3. Okay, so we have everything. So let's start out with the sine of theta plus beta. So again, it's the sine of theta times the cosine of beta, then plus your cosine of theta times your sine of beta. So the sine of theta is negative 15 over 17. The cosine of beta is negative 3/5. The cosine of theta is negative 8 over 17. And the sine of beta is going to be negative 4/5. So let's just crank this out. Again, because I have 17 times 5 here and 17 times 5 here, I'm not going to cancel anything. Just going to go through and do the multiplication. So negative 15 times negative 3 is 45. And then let's just write this with the common denominator now. Negative 8 times negative 4 is 32. So plus 32 over the common denominator of 17 times 5, which is 85. So this gives me, let me make that 5 a little bit better there. 45 plus 32, that's going to be 77, and this is over 85. So that's my sine of theta plus beta. Okay, so let's just bring that to a new sheet, and I'll put the tangent of theta plus beta right here. Let's go get that. Okay, so for the tangent of theta plus beta, this is the tangent of theta plus the tangent of beta over 1 minus the tangent of theta times the tangent of beta. So let's see what we're going to have. So the tangent of theta is 15 over 8. Then plus the tangent of beta is 4/3. This is over 1 minus the tangent of theta, again, is 15 over 8. And then times the tangent of beta, which is 4/3. Okay, so lots of different ways to simplify here. Again, the strategy I'm going to use, you could multiply this together now. I would not cancel anything because you have an 8 and a 3 and then an 8 and a 3. And if you go through and cancel, you're going to end up with the same answer. So what I'm going to do is say this is going to be 15 times 4, which is going to be 60 over 8 times 3, which is 24. So we don't have to reduce that right now, because what I'm going to do is say this is 24 over 24 that I'm going to multiply by, because you have 8, 3, and 24 for the denominators, so the LCD is 24. So this would get distributed, and we would say 24 divided by 8 is 3. 3 times 15 is 45. Then plus 24 divided by 3 is 8. 8 times 4 is 32. And this is over 24 times 1 is 24. And then minus 24 divided by 24 is 1. So you basically just have 60. So 45 plus 32, that's going to be 77. And this is over 24 minus 60, which is negative 36. So this is negative 77 over 36. So let's write negative 77 over 36. For the quadrant of theta plus beta, sine is positive, tangent is negative. So let's think about this. Again, if I use my poorly drawn coordinate plane here, all students take calculus. In the first quadrant, they're both positive. So that's out because this is negative. In the second quadrant, sine is positive and tangent is negative. So that's where I am, because if I go to quadrants 3 or 4, sine is going to be negative, right? So it's got to be in quadrant 2 where sine is positive and tangent is negative. So I'm just going to say that theta plus beta is in quadrant 2. All right, for the next two problems, the instructions tell us to verify each identity. And let's start with problem number 13. So we have the tangent of theta plus 1 over 1 minus the tangent of theta is equal to the tangent of theta minus 135 degrees. So what I'm going to do is work on the right side here. This side will be unchanged. So this is what we're going to try to get a match with. Let me put my equals all the way over here. And I'm going to use my difference identity for tangent. So let me scroll down just a little bit. And I'll start off by saying this is the tangent of theta. Again, this sign always matches. So this is a minus the tangent of 135 degrees. And then over, you're going to have your 1. And again, this sign is always different from this sign. So this is a plus. And you're going to multiply this by this. So the tangent of theta then times the tangent of 135 degrees. Now, we saw earlier that the tangent of 135 degrees is negative 1. So you would just plug this in here and here. So we'll say that this equals, let me come down here a little bit, the tangent of theta. And then basically you have minus a negative 1, which is plus 1. Let me scroll up just a little bit. And you can see that matches what we have there. Then this is over. You're going to have 1. And then basically, instead of the plus, this becomes tangent of theta times negative 1, which is just the negative of the tangent of theta. So you just put minus tangent of theta, and so we have a match, right? So tangent of theta plus 1 over 1 minus the tangent of theta. And here the tangent of theta plus 1 over 1 minus the tangent of theta. So I'll just put a check mark. All right, for problem 14, we're going to verify this identity. So we have the cosine of, you're going to have this theta minus beta over the cosine of theta times the sine of beta. This is equal to the tangent of theta plus the cotangent of beta. So let me actually flip this. This is going to be the simpler side. And this is how I like to format it. So let me put the tangent of theta plus the cotangent of beta. And this is equal to, again, I'm just going to copy this. So the cosine of theta minus beta, and then over the cosine of theta times the sine of beta. Okay, let me come down here a little bit, and I'll put the equals all the way over here. I'm going to use my cosine difference identity here for the numerator. So this is the cosine of theta, then times the cosine of beta. Then this is a minus, so I want a plus. And this is the sine of theta times the sine of beta. Okay, now what you could do is actually split this up and put this part over this denominator. So this would be the cosine of theta times the sine of beta, and then put this part over the denominator. So the cosine of theta times the sine of beta. Again, if you are confused about this, if you were presented with this, you have a common denominator, so you could write it as the cosine of theta times the cosine of beta plus the sine of theta times the sine of beta over the common denominator of the cosine of theta times the sine of beta. So from here, what I would do is actually cancel this and cancel this. So what you have now is the cosine of beta over the sine of beta. That's going to be the cotangent of beta. And then plus the sine of theta over the cosine of theta is the tangent of theta. So we're almost there. Remember, the order was flipped, so we want to match that. We're just going to change the order of the addition here and say this is the tangent of theta plus the cotangent of beta, and we're done. All right, let's take a look at our practice test. For the instructions, we're asked to derive the given identities. For the first problem, we have cosine of 2a. So here's where we're going to go back to the little handout. And if we scroll down on this guy, we can come down to this section right here where you see the double angle identities, and you see the cosine of 2a is equal to cosine squared a minus sine squared a. And then you have these other forms, but I'm just going to do this one. These you can get by algebraically manipulating this one. So let's go back. And the first thing I'm going to do is just write this as the cosine of a plus a. So a plus a is 2a. Now what I'm going to do is use my sum identity for cosine. So I'm going to say that this is the cosine of a times the cosine of a. And then again, if this is a plus, you want a minus. So now we have the sine of a times the sine of a. So real easy here. Cosine of a times cosine of a is going to be cosine squared a. And then minus sine of a times sine of a is going to be sine squared a. So that's all it is. Okay, let's look at problem 2. So now we have the sine of 2a. And again, coming back to the handout, we have the sine of 2a is equal to 2 times the sine of a times the cosine of a. So that's what we're looking for. So to start out, I'll say this is equal to my sine of, again, a plus a, just like we did in the last example. A plus a is 2a. And so this is equal to, again, you just use your sum identity for sine. So we'll say this is the sine of a times the cosine of a. And then the sign here is always going to be the same. So this is a plus, so I want a plus. And then I want to do the cosine of a and then times the sine of a. So what is this equal to? Well, basically I have the sine of a times the cosine of a, and then I have the sine of a times the cosine of a. Remember, you can multiply in any order. So I could flip this around and say that this is the sine of a times the cosine of a as well if I wanted to. So let me actually write it like that. So this is the sine of a times the cosine of a, and then plus the sine of a times the cosine of a. So that means I have 2 of this guy right here. Right? So I could just say this is 2 times the sine of a, and then times the cosine of a. So that's our formula. Okay, let's take a look at problem 3. So we have the tangent of 2a. Let's go back to our handout and come down to this guy right here. So the tangent of 2a is equal to 2 times the tangent of a over 1 minus tangent squared a. So another real easy one to get. So just start out by saying this is the tangent of a plus a. And so this is equal to what? Use your sum identity for tangent. So this is the tangent of a. And then remember, this sign is always going to be the same. So this is plus your tangent of a. And this is over 1. And then this sign is different. So this is a plus. You want a minus. So you have the tangent of a and then times the tangent of a. So a real easy formula. Tangent of a plus tangent of a is just going to be 2 times the tangent of a. Then this is over. You have 1 minus tangent of a times tangent of a is tangent squared a. All right, let's take a look at problem 4. So we have the cosine of a times the cosine of b. And so if we look at our little handout and we come down to the product to sum identities, I'm not going to derive all of these. I'm just going to do the first one. The other ones you can get using a similar strategy. So for this one, we want to end up with 1/2 times this quantity. You have the cosine of a plus b and then plus the cosine of a minus b. So what I'm going to do to get this formula is start out with the cosine of a plus b and then plus the cosine of a minus b. And we'll just see what happens. So let's come up here, and I'm going to start with the cosine of a plus b. And this is equal to the cosine of a times the cosine of b. And then if this is a plus, you want a minus. Then you have the sine of a, and then times the sine of b. Okay, let me do the other guy. So we have the cosine of a minus b. So it's the same thing as this. You're just going to change the sign in the middle. So this is the cosine of A times the cosine of B. Now this is a plus. You have the sine of A and then times the sine of B. So for the next step, what I'm going to do is just add the left sides, set this equal to the sum of the right sides. So here you would just write this as the cosine of A plus B, and then plus the cosine of A minus B. And then what's going to happen here is this is equal to this plus this. You have cosine of A times cosine of B plus the cosine of A times the cosine of B. Well, that's just 2 times the cosine of A times the cosine of B. Now this part right here is going to cancel away, right? You have the negative of sine of A times sine of B plus sine of A times sine of B. That's just going to be 0 and go away. So at this point, we're almost there. We need to divide both sides by 2, or you could multiply both sides by 1/2. So let's just go ahead and say, and I'm going to flip this around, that this is the cosine of A times the cosine of B. So that's what we're trying to figure out. And this is equal to, I'm going to go 1/2 times this guy right here. So the cosine of A plus B, and then plus your cosine of A minus B. All right, for the next few problems, we're asked for the instructions to find the exact function value. So for problem 5, we're given that theta is in quadrant 2, and we want to find the sine of 2 theta. So before we do any work, let's just come back down to the handout, and I'm going to go to the double angle identities, and you see for the sine of 2a, you have 2 times the sine of A times the cosine of A. So let's write out that the sine of 2 theta is equal to 2 times the cosine of theta times the sine of theta. Now we're given the tangent of theta, and this equals negative 12 over 5. Okay, how can we find the sine of theta and the cosine of theta so that we can plug into this formula here and figure out the sine of 2 theta? Well, the easiest way here is probably just to go back to our original definition. We know that if I'm in quadrant 2, the x values are negative and the y values are positive. The tangent is going to be your y over your x. So what we'll say here is that the x value is negative 5 and the y value is positive 12, right? So this is basically 12 over negative 5, which gives me the negative 12 over 5. Now, what's the r value? Without even thinking about it or going into any detail, most of you know, forget about the fact that this is negative, you have a 5, 12, 13 right triangle, right? That's a special right triangle. But again, you can go through and crank this out. R is equal to the square root of x squared plus y squared. So my x is negative 5. Negative 5 squared is 25. And then my y is 12. 12 squared is 144. And then 25 plus 144 is 169. And then if you take the square root of 169, you will get 13. Okay, so that's where you get that. Again, if you recognize that you have a 5, 12, 13 right triangle, then just throw 13 in there and be done with it. All right, so the next thing I would think about here is building my sine of theta. So that is y over r. In this case, your y is 12 and your r is 13. And then my cosine of theta is x over r. In this case, my x is negative 5. Let me put the negative out in front. And then my r is 13. Okay, so we have the sine of theta. We have the cosine of theta. So if we want to figure out the sine of 2 theta, again, just plug into that formula. So let me write this down here. We're going to go off the screen. Let me come down here and say that my sine of 2 theta is equal to 2 times. The sine of theta is 12 over 13. And then times the cosine of theta, which is negative 5 over 13. So this gives me, nothing's going to cancel. So 2 times 12 is 24. 24 times negative 5, that's going to be negative 120. And this is over 13 times 13 is going to be 169. So the answer for the sine of 2 theta, it's going to be the negative of 120 over 169. All right, let's take a look at problem 6. So theta is in quadrant 2. We want to find the cosine of 2 theta. And going back to the handout, you have this one that says the cosine of 2a is equal to 1 minus 2 times the sine squared a. I would use that one in this case. So let me slide down here a little bit. And I will just say that the cosine of 2 theta is equal to 1 minus, you have 2 times sine squared theta. So let's just plug in here. So for the sine of theta, it's going to be the square root of 231 over 20. So the square root of 231 over 20. And then we need to square this. So what's that going to give me? Well, let me write, this is 1 minus 2 times the square root of 231 squared is just 231. This is over 20 squared is going to be 400. Now what I can do is cancel a common factor between here and here. So 2 divided by 2 is 1. 400 divided by 2 is 200. So this would be equal to, let me write this with a common denominator. So 200 over 200. And then minus, you'll have 231 over 200. So this would be equal to 200 minus 231 is negative 31. And this is over the common denominator of 200. So this would just be negative 31 over 200 for the cosine of 2 theta. All right, let's take a look at problem 7. So now we're told that theta is in quadrant 4, and we want to find the cosine of 2 theta. So here we're given the cosine of theta, and this is 5 over 13. So going back to the handout, I would pick this guy right here where it says cosine of 2a is equal to 2 times cosine squared a minus 1. So let me say that the cosine of 2 theta is equal to 2 times cosine squared theta and then minus 1. So coming down here, I'll just replace this cosine squared theta with 5 over 13, and then I'm going to square that. So that gives me what? Let me scroll down here just a little bit. I will say that this is 2 times 5 squared is 25, and 13 squared is 169. Nothing to really cancel there, so let me just write this right now as 50 over 169, just doing that multiplication of 2 times 25. And then minus, let me get a common denominator. I'll say this is 169 over 169, and this equals 50 minus 169. Let's do that on the calculator, and you're going to get negative 119. So let's say this is negative 119 over 169. Now this is not going to simplify any further, so this is going to be your answer for the cosine of 2 theta. All right, let's take a look at problem 8. So now we're told that theta is in quadrant 1. Find the tangent of 2 theta. So there's a lot of strategies for this. You have your tangent of 2a is equal to 2 times the tangent of a over 1 minus tangent squared a. So you could use that formula if you want. So basically you could find out what is the cosine of theta, and then you could build out your tangent of theta, and then you can plug into the formula to find the tangent of 2 theta. You could also find the sine of 2 theta and the cosine of 2 theta, and then you could just do the division, find the tangent of 2 theta. So whatever you want to do, I'm just going to go with the first route here. So I would notice that this is going to be an 8, 15, 17 right triangle, right? I'm in quadrant 1. And again, if you don't know that, you can think about sine of theta as y over r, right? So my y value is going to be 15, and my r value is going to be 17, okay? So you could just plug in to the r is equal to the square root of x squared and then plus y squared. Now I know that y is 15, so this would be 225 here. And this would be 17 here. You've got to get rid of the square root. So what I would do is square both sides. So this would be 289 over here. And if I square this side, this would go away. Subtract 225 away from each side. You would end up with 64 is equal to x squared. And again, we're going to be in quadrant 1, so my x values are going to be positive. So I would want the principal square root here, and I would just say that x is equal to 8. Okay, but again, if you notice this is an 8, 15, 17 special right triangle, then you can just immediately say that x is 8 there. Let me get rid of this, and I'll just say that x is going to be 8. So now cosine of theta is x over r, so it's 8 over 17. So very simple. Let's get rid of this and come down here. And for the tangent of theta, it's your sine value, so 15 over 17, divided by your cosine value, so 8 over 17. I'm dividing with fractions, so take the first fraction, multiply by the reciprocal of the second fraction. And so we see that this is going to cancel, and I have 15 over 8. All right, so for the tangent of 2 theta, it's going to be 2 times your tangent of theta over 1 minus tangent squared theta. So the tangent of theta is 15 over 8. And then tangent squared theta, so that's 15 over 8 squared. Okay, let me make this a little bit better here. Now, you can go through and say that this 2 would cancel with this 8 and give me a 4. 15 squared is 225, and 8 squared is 64. So this is 225 over 64. Let me get rid of this and write this more cleanly. What I would do is multiply the numerator by 64 and the denominator by 64. That'll clear all the denominators out. So let me show this like this. So this would be equal to 64 divided by 4 is 16. 16 times 15, that's going to be 240. And this is over. You would have 64, and then minus the 64s would cancel there. You're 225. So this would be equal to 240 over 64 minus 225. It's going to be negative 161. So that would be your answer. You're not going to be able to simplify that any further. So the tangent of 2 theta is negative 240 over 161. All right, for the next few problems, the instructions tell us to verify each identity. And for problem 9, we have 2 times sine squared x times the quantity 1 plus cotangent of x is equal to sine of 2x minus cosine of 2x plus 1. I'm going to flip this for formatting. So I'm going to put that we have the sine of 2x minus the cosine of 2x plus 1 is equal to this 2 times my sine squared x times the quantity 1 plus the cotangent of x. Okay, so here's how I'm going to do this. I'm going to make this right side match this left side. Let me put my equals over here so I have some room. We'll slide down a little bit. So I'm going to distribute this in. So I'm going to say this is 2 times sine squared x, and then plus, you would have 2 times sine squared x times cotangent of x. Now, the cotangent of x is the cosine of x over the sine of x. So let's write this as 2 times sine squared x plus 2 times sine squared x times cosine of x over sine of x. Now I can cancel one of these with this. So now if you look at it, you have 2 times sine of x times cosine of x. Going back to our handout, if I have 2 times the sine of a times the cosine of a, that's the sine of 2a. So I want to replace this with the sine of 2x. So I'll say that this 2 times the sine of x times the cosine of x, this is going to be the sine of 2x. So at this point, I have this part right here. What I need is this negative cosine of 2x plus 1. So how do I get that? Well, look at this 2 sine squared x and come back to the little handout. See this guy right here where it says cosine of 2a equals 1 minus 2 times sine squared a? Let me write that out. So if we have the cosine of 2a, this is equal to 1 minus 2 times sine squared a. So what I'm going to do is subtract 1 away from each side. So let me put minus 1 here and then plus this here. And I'm going to get rid of this from here. And then just multiply both sides by negative 1. So this would now be a plus and this would be a minus. And this is what I'm going to substitute in for this right here. That way I can get my positive 1 and my negative cosine 2x. Okay, this is exactly what I want. So I'm going to say that this is equal to here, this 1 minus the cosine of, in this case we're working with x, so cosine of 2x. Let me get rid of this, and then you could just reorder it to make it match this guy right here exactly. So I'm just going to say that this is equal to, you'll have your sine of 2x, and then minus your cosine of 2x, and then lastly, plus 1. And so we verified our identity. Let me just put a check mark to show we're done. All right, let's take a look at problem 10. Here we have our cosecant squared x over sine squared x plus cosine of 2x. This is equal to tangent squared x plus 1 over sine squared x. All right, I'm definitely going to think this side is simpler. So let me write this again. So I'll say this is the tangent squared x plus 1 over my sine. Let me make this a little bit better here. So my sine squared x. This will be equal to cosecant squared x over sine squared x plus cosine of 2x. Okay, let me put equals all the way over here. So remember at the beginning of the practice test, we derived this guy. So the cosine of 2a is equal to cosine squared a minus sine squared a. So I'll say this is cosecant squared x over sine squared x. And then plus cosine of 2x I could write as cosine squared x minus sine squared x. And make this a little bit longer here. Now, sine squared x minus sine squared x is going to be 0, right? So this and this, those are going to cancel. So let's say now this is equal to the cosecant squared x over cosine squared x. Now, if you think about what you have here, you have sine squared x in the denominator. Well, here it's cosecant squared x, which is 1 over sine squared x. So you can immediately do that one. So I'll go ahead and say that this is 1 over sine squared x, and then times, you have 1 over cosine squared x, which is really secant squared x. Now, you're trying to get tangent squared x plus 1 in the numerator. Secant squared theta is equal to tangent squared theta plus 1. So coming back down, I'll go ahead and say that secant squared x is tangent squared x plus 1, and we'll be done. So we'll say that this is tangent squared x plus 1 over sine squared x. Let me make this a little bit better so we don't think this is 2x. So this is a squared here. And so we're done here. We've verified our identity. So let me put a check mark there. All right, for the next few problems, the instructions tell us to find the exact value of each expression. So for problem 11, we have 3 times cosine of 5 pi over 12 times sine of 13 pi over 12. So we're going to come back to the handout and come down here to where we have our product to sum identities. So in this particular case, we have cosine of some angle times sine of some angle. So it looks like we want to use this last formula here. So I'm just going to copy it down and come back. So we have the cosine of A times the sine of B is equal to, let me scooch this down a little bit so it fits, or actually I'll just write it down here. So this is going to be 1/2 times, you have your sine of A plus B, and then minus your sine of A minus B. Okay, so let me close this down like this. So this is what we want to do. Let me scroll down here a little bit, and you're just going to plug into the formula. It's pretty easy overall. So first off, you have this 3. Just put that outside for now. So I'm going to put the 3 outside, and you can use brackets or parentheses or whatever you want to do. Then you have the 1/2, and then let me use brackets again. So you have your sine of A plus B. So this is your A, this is your B. So you would have 5 pi over 12, and then we're going to say plus 13 pi over 12. Let me make that 13 a little bit better there. And let me put an equals here and just drag this over here so we know what's going on. And then we'll put minus the sine of A minus B. So this is your A, this is your B. So you have 5 pi over 12, and then minus 13 pi over 12. And let me close down the brackets here. So we have this one, and then we also have this one. So you have 2 sets of brackets. And so what we'll do from here is say this is 3 times 1/2, which is 3/2. Put my brackets in there. So this would be the sine of 5 plus 13 is 18, and 18 over 12, each is divisible by 6. 18 divided by 6 is 3, and 12 divided by 6 is 2. So this is 3 pi over 2. Okay, so you want sine of that, and you don't need parentheses here. And then minus the sine of, you're going to have 5 minus 13, which is negative 8 over 12. Now forget about the fact that it's negative. If you have 8 over 12, 8's divisible by 4. 8 divided by 4 is 2. And then 12 divided by 4 is 3. So this would be 2 pi over 3. Now, it's a negative here. And remember, sine is an odd function. So I can pull the negative out and basically change this minus here into a plus. Okay? So then I'll put this as being closed down here. So we have our 3/2 on the outside of the brackets. Hopefully you know that the sine of 3 pi over 2 at this point is going to be -1. So this is -1. And then plus sine of 2 pi over 3. Remember, 2 pi over 3 is 120 degrees. So the sine of 120 degrees, you have a 60-degree reference angle. The sine of 60 degrees is square root of 3 over 2. You're in quadrant 2, so it's going to be positive. So this is the square root of 3 over 2. Let me close that down. So you could add inside the brackets first, or you could distribute. Really doesn't matter. So let me just go ahead and distribute this. I'll say this is -3/2, and then plus, this would be 3 times square root of 3 over 4, right? 2 times 2 would be 4. So now let's just write this with a common denominator. I'm going to multiply this by 2 over 2, And so that would give me negative 6 plus 3 times square root of 3 over 4. All right, let's take a look at problem number 12. So we have negative 3 times the quantity sine of pi over 12 plus the sine of 5 pi over 12. Okay, so let's go back to the little handout. And in this case, what you're going to want is this first guy right here. So sine of A plus sine of B equals 2 times the sine of A plus B over 2 times the cosine of A minus B over 2. So let's scroll down just a little bit. I'll put the negative 3 out in front. And then again, for the formula, it's 2 times the sine of, you're going to go A plus B over 2. So this guy plus this guy over 2. So let me go pi over 12 plus 5 pi over 12 over 2, like this. So let me just stop and do this now so it doesn't get so messy. So we know that we have a common denominator. 1 pi plus 5 pi would be 6 pi. So this would be 6 pi over 12. So 6 pi over 12. And I'm dividing by 2, so that's the same thing as multiplying by a half. And so here, let's just go ahead and cancel this with this. And that is going to give me a 3 up here. And then 12 divided by 3 would be 4. So this is going to end up being pi over 4. Okay, so we'll want 2 times sine of pi over 4. So now you're going to have times the cosine of, you want this angle minus this angle. So now we want to go pi over 12 minus 5 pi over 12. And then we're going to divide by 2. So 1 pi minus 5 pi would be negative 4 pi. So this is negative 4 pi over 12. Again, I'm dividing by 2, so this is the same thing as multiplying by a half. And so I could cancel here first or here first. It doesn't really matter. So I'm going to cancel this with this and say I have negative 2. So then 12 divided by 2 would be 6. So this is going to end up being negative pi over 6. So this is negative pi over 6. Now, cosine is an even function. So the cosine of negative pi over 6 is the same as the cosine of pi over 6. So you can get rid of this negative if you want. Okay, let's close this down. And from here, it's pretty easy overall. You would say that this is negative 3 times, you have your sine of pi over 4. So pi over 4, again, is 45 degrees. And for the sine of 45 degrees or the cosine of 45 degrees, it's square root of 2 over 2. So this is 2 times square root of 2 over 2, and then times the cosine of pi over 6. So pi over 6 is 30 degrees, and the cosine of 30 degrees is the square root of 3 over 2. Let me close this down, and we'll keep going. So this is going to be negative 3 times, you can just drop the parentheses at this point because it's all just straight multiplication. So we would have this 2 canceling with this 2. So let's put the square root of 2 and then times the square root of 3. And this is all going to be over 2. Now, if I finish this up, I'll just say that this is negative 3 times the square root of 6. Square root of 2 times square root of 3 is square root of 6. Nothing you can really do with that, over 2. So this is as simple as we can make this. So you could say the negative of 3 times square root of 6 over 2. All right, for the next part, the instructions say to write the product as a difference. So for problem 13, we have the cosine of 8 theta times the sine of 2 theta. So this is a product right now. We're multiplying these guys together, and we want to write it as a difference. You want to go up to the product to sum. So right now, you want to use this one. The cosine of A times the sine of B is 1/2 times the quantity sine of A plus B minus the sine of A minus B. So this is equal to 1/2 times, again, you're going to have this quantity where you do the sine of A plus B. So this is A and this is B. So 8 theta plus 2 theta. Let me write this out so nobody's lost. So 8 theta plus 2 theta. And then basically from there, you're going to go minus. You're going to have your sine of now A minus B. So this would be 8 theta and then minus 2 theta. Let me close this down. So let me say this equals, you have 1/2 times this quantity. The sine of 8 theta plus 2 theta, we can just say this is the sine of 10 theta. And then minus the sine of 8 theta minus 2 theta would be 6 theta. So I'll just distribute the 1/2 to each guy here. So this would be sine of 10 theta over 2 minus sine of 6 theta over 2. And of course, you could write that with a common denominator if you wanted to. So you could say this is the sine of 10 theta minus the sine of 6 theta over 2. All right, for the next guy, the instructions say to write the sum as a product. And for this one, for problem 14, we have 2 times the quantity sine of 13b plus the sine of 3b. So right now, this is a sum, and we want it as a product. So let's come back, and we want to look for the sum to product identities. So we have the sine of a plus the sine of b. So this is the one we want. So it's 2 times the sine of a plus b over 2 times the cosine of a minus b over 2. Okay, this one's tricky because you have a 2 already out front. So don't make the mistake of just putting 1, 2. You need a 2. And then the formula is 2 times your sine of a plus b. So this is your a and this is your b. So this is a and this is b. So I'm going to go 13b plus 3b, and this is divided by 2. And then you have times your cosine of, now you're going to do a minus b and divided by 2. So 13b minus 3b, and this is divided by 2. Let me close this down and close this down. So let me go 2 times, you have 2 times the sine of 13 plus 3 is 16. 16 divided by 2 is 8. So this is just 8b. Let me drop these parentheses here. So this is 8b here. And then times the cosine of 13 minus 3 is 10. So this would be 10b over 2. And 10 divided by 2 is 5. So this is the cosine of 5b. So close this down. And to finish this up, 2 times 2 would be 4. So this is 4 times the sine of 8b times the cosine of 5b. All right, let's take a look at the practice test. For the instructions, we're asked to derive the given identities. For the first problem, we have the cosine of a over 2. So let's go back to the handout and let's scroll down to where we have the half angle identities. So this is the one we want, the first one where it says cosine of a over 2 is equal to plus or minus the square root of 1 plus the cosine of a over 2. So where does that come from? Let's scroll back up. We need to go to the last section where we talked about these double angle identities. And we're going to start with this one that says the cosine of 2a is equal to 2 times cosine squared a minus 1. What we're going to do, instead of using a, we're going to use x, because we're going to do a little substitution at the end. Where there's an x, we're going to plug in this a over 2. So let's write out our little double angle identity to get started. So the cosine of 2x is equal to, again, this is 2 times cosine squared x and then minus 1. Now, what you're going to end up doing is getting cosine of x on one side and then everything else on the other. And again, like I just said, you're going to plug in this a over 2 everywhere there's an x. So you can pause the video and try that now, or you can just go through this with me, either way. Since I want the cosine of x on one side by itself, let me add 1 to both sides like this. And so this will give me the cosine of 2x plus 1 is equal to 2 times cosine squared x. Now I'm going to write this on the left and this on the right. So I'm just going to switch the sides. Remember, that's completely legal. So I'm just going to say this is 2 times cosine squared x is equal to cosine of 2x. Instead of putting plus 1 with the formula, it's actually 1 plus this guy here. So 1 plus cosine of 2x. From here, what I would do, since again, I want cosine of x by itself, I'm just going to divide both sides by 2. So I can get rid of this 2 right here. And so now I have cosine squared x is equal to, I have 1 plus cosine of 2x over 2. Now I'm going to use my square root property here. So this side on the left will just be the cosine of x. But over here, you have to remember that you want plus or minus the square root of this guy. So 1 plus the cosine of 2x over 2. So you need this plus or minus here because, again, cosine would be positive in quadrants 1 and 4, and then it's negative in quadrants 2 and 3. Okay, so based on the quadrant that you're in, you would choose the appropriate sign. So that's why you have the plus or minus. Now, we are not quite at our formula. So here we have the cosine of x is equal to plus or minus the square root of 1 plus cosine of 2x over 2. The idea here is that you have x and then you have 2x. So you're going to plug in an a over 2, or you could do theta over 2 or whatever you're working with everywhere there's an x. So basically, you're just going to say that this is the cosine of, let's just say this is a over 2, and this is equal to plus or minus, and I don't think this is going to fit. I didn't give myself enough room and bring this down here. So the square root of 1 plus the cosine of 2. Again, where there's an x, so here and here, you're plugging in a over 2. And then this is over 2 like this. So now this is going to simplify. So this 2 divided by this 2 would be 1. So you arrive at the formula. So this is the cosine of a over 2 is equal to plus or minus the square root of 1 plus, you would just have the cosine of a over 2. All right, let's take a look at problem 2. So now we have the sine of a over 2. So going back to our handout, if we come back again to the half angle identities, so the second one here is what we want. So the sine of a over 2 is equal to plus or minus your square root of 1 minus the cosine of a over 2. So coming back up to the double angle identities, we want the third one that says the cosine of 2a is equal to 1 minus 2 times sine squared a. So let me write this down here. And instead of a, I'm going to use x. So we'll have the cosine of 2x is equal to 1 minus 2 times your sine squared x. Now I'm using x here because, again, what we're going to do is isolate sine of x on the left side, and then what's going to happen is you're going to plug in an a over 2 everywhere there's an x, and you'll get that formula. So if I want to isolate the sine of x, well, what I would do first is let's subtract 1 away from each side, so that would cancel. Let's say now that this is negative 1 plus the cosine of 2x. And I'm just writing it like that because that's the order it's going to end up in. So let's say this is equal to, over here, this is negative 2 times the sine squared x. So now what I'm going to do is just write this one over here. So negative 2 times sine squared x. And this equals negative 1 plus cosine of 2x. All right, I'm just going to divide both sides by negative 2. And I'm going to split this up here to make it easier to understand. This will cancel. So now I have my sine squared x, and this equals, basically I'm just going to put negative over negative as positive. And so I'm going to write this as 1/2. Positive over negative would be negative, so let's put minus. You have cosine of 2x over 2. Now, a lot of people try to cancel this with this. That is illegal, okay? This is on the inside here, right? So this is the cosine of 2x and then divided by 2. So don't go through and cancel this with this, okay? That's illegal. You don't want to do that. So now what I would do from here is say that this is sine squared x is equal to, I'm going to write this with a common denominator. Let me scooch this down just a little bit. This would be 1 minus the cosine of 2x over the common denominator of 2. Let's come to a fresh sheet here so we don't run out of room. So now I would just use my square root property. So you would have the sine of x is equal to, again, you need that plus or minus because with sine, it's positive in quadrants 1 or 2, and then it's negative in quadrants 3 or 4. So let's go ahead and say this is the square root of 1 minus the cosine of 2x over 2. Now, the last thing, you have an x here and an x here. You're just going to plug in an a over 2 or a theta over 2 or whatever you want to use. So that would give me the sine of a over 2. Let me make this s a little bit better here. And this is equal to plus or minus the square root of 1 minus the cosine of 2 times your a over 2. So see how this is on the inside here? So you can cancel this. This is okay because it's on the inside of what you're trying to do, okay? If you had cosine of 2x over 2, you cannot cancel those 2's there. But if you have the cosine of 2x over 2 like this, right, it's inside here, then you can cancel the 2's. So hopefully you understand the difference between those two different situations. I know that trips up a lot of people. So let's go ahead and just cancel this right now and say that this is the cosine of a, and then this is all over 2. So this is your formula. The sine of a over 2 equals plus or minus the square root of 1 minus the cosine of a over 2. Okay, let's look at problem 3. So here we have the tangent of a over 2. And going back, let's look at this guy right here. So for the half angle identities, you actually have 3 of them for the tangent of a over 2. I'm just going to do the first one here where it says the tangent of a over 2 is equal to plus or minus the square root of 1 minus the cosine of a over 1 plus the cosine of a. And what I'll do here is say that this is the sine of a over 2. So we just did that one over the cosine of a over 2. So this would be equal to, for the sine of a over 2, we said this was plus or minus the square root of 1 minus the cosine of A over 2. And then this would be over your cosine of A over 2. So this is plus or minus the square root of 1 plus the cosine of A over 2. Okay, so how are we going to simplify this? It's actually pretty easy overall. First and foremost, if you have plus or minus over plus or minus, just think about the fact that you could either have the same signs or different signs, so you're going to end up with plus or minus again. Okay, so that's very simple to understand. If that's confusing for you, you can just try things out. You could do something like, okay, what if I had the square root of 9 times, let's say, the square root of 4? Well, principal square root times principal square root, this would be 3, this would be 2, that would give you 6. If you now change this to a negative, well, now you would have a negative. And then if both of these were negatives, well, now you go back to having a positive. Okay, so if you see plus or minus times a plus or minus divided by a plus or minus, you end up with a plus or minus, right? Because you're either getting the same sign or you're getting different signs. So once you have that established, let me put plus or minus here, then you can make a big square root. And again, if you have the square root of something divided by the square root of something else, so something like the square root of A over the square root of B, this is the square root of A over B. Okay, so you can just combine it like that and say that this is 1 minus the cosine of A over 2. Let me come down here a little bit. And actually, let me make this square root sign a lot bigger. So all the way like this. So this is divided by 1 plus the cosine, let me make that a little bit better there, of A over 2. And let me drag this down here so it's a little bit better formatted. Now what you would do, since you have one fraction divided by another, you would just say this is plus or minus the square root of 1 minus the cosine of A over 2. So the top fraction here, leave that alone. You're going to multiply by the reciprocal of this bottom fraction here. And I'm talking about in terms of this complex fraction. This is the fraction in the numerator. This is the fraction in the denominator. So leave this one unchanged, multiply by the reciprocal of this one. So I'm going to put the 2 up here, and then the 1 plus the cosine of A down here. Maybe I can make the S a little bit better. And so the 2's are going to cancel. And so what does this give me? Well, at this point, I have my formula. So it's going to be plus or minus the square root of 1 minus the cosine of A over 1 plus the cosine of A. So that's what we're looking for. All right, for the next few problems, the instructions tell us to find the exact value. And for problem 4, we have the sine of 345 degrees. So for this one, you could use your half angle identity. Again, the sine of A over 2 is equal to this plus or minus the square root of 1 minus the cosine of A over 2. But what you would want to do first is think about, okay, if I want to use A over 2, well, I need to double this first and then divide by 2. But in this particular case, if I double 345 degrees, I'm going to end up with 690 degrees, and I like to work with something that's between 0 and 360 degrees. So what I would do here is think about the concept of a reference angle, which we learned about earlier on in the course. So if I'm in quadrant 4, the reference angle is 360 degrees minus your angle. So in this case, 360 degrees minus 345 degrees, so it's 15 degrees. So this would be equal to the sine of 15 degrees. But again, you got to think about what quadrant you're in. I'm in quadrant 4, so I know that sine is negative, right? So I want to put the negative of the sine of 15 degrees. So let's say this equals now. It's going to be a little bit easier to work with our formula. Let's say the negative of, I'm going to go the sine of, I'm going to double this. So 15 degrees doubled or times 2 is going to be 30 degrees. And then I'm just going to divide it by 2 like this. Okay, so this would be equal to, again, you have the negative of, with your formula, you have the plus or minus, but I know that in this case, it's going to be a negative, right? Because this angle that I'm working with, the 345 degrees, is in quadrant 4. So that's why I want to make sure I have that negative. That's why I have it here and here and here, okay? So then I would just put the square root here, and then the formula is 1 minus the cosine of whatever angle you're working with. Now this is going to be this guy right here in this position, in the top position. Remember, it's A over 2, and this is your A that's going right here. So this is going to be 30 degrees, and then this is over 2. So real simple formula to work with. Let's come down here and just say this is equal to the negative of the square root of 1 minus, we all know the cosine of 30 degrees is square root of 3 over 2. So this is square root of 3 over 2. And then this is over 2. Let me make this a little bit longer here, so that's more consistent. So let me move this out here. And actually, let me move this down. Okay, so the quickest way I think to simplify this is to multiply the numerator and denominator of the complex fraction by 2. And so what is that going to give me? So the negative of the square root, 2 times 1, let me show this here. 2 times 1 is 2. And then minus, if you do 2 times the square root of 3 over 2, the 2's are going to cancel, so you just get the square root of 3. And then down here, 2 times 2 would give me 4. So let's break this up and say this is the negative of the square root of 2 minus the square root of 3 over the square root of 4 is 2. So this would be my final answer here. So it's the negative of the square root of 2 minus the square root of 3 over 2. All right, let's take a look at problem 5. So here we have the cosine of 112.5 degrees. So again, I would just double this angle and divide by 2. That way I can use my half angle formula. So 112.5 degrees times 2, that's going to give me 225 degrees. So this is the cosine of 225 degrees divided by 2. Now, whenever you use the formula, again, you always think about the original angle. Don't worry about this angle up here. Okay, this is just for us to plug into the formula. I am trying to find the cosine of 112.5 degrees. So think about the sine based on where is that guy. So this guy right here is going to be in quadrant 2, so cosine is negative. So this is equal to the negative of the square root. This is 1 plus the cosine of, this is your a up here, so this is 225 degrees, and this is over 2. All right, at this point, I think we know what the cosine of 225 degrees is. You have a 45-degree reference angle, and you're going to be in quadrant 3. So the cosine of 45 degrees is square root of 2 over 2. In quadrant 3, cosine is negative. So this would be the negative of the square root of 2 over 2. So let's say this is equal to, we'll have negative square root of 1, and then minus the square root of 2 over 2. And then this is over 2 like this. You need to make these longer. So let me do this like that. And then just like I did in the last problem, we're just going to multiply this by 2 over 2. And so this is going to get distributed here, and this will go here. So this equals the negative of your square root. 2 times 1 is 2, and then minus the 2's would cancel, so you just have the square root of 2. And this is over 2 times 2, which is 4. So again, easy to break this up and just say this is the negative of the square root of 2 minus the square root of 2 over the square root of 4 is 2. And you can move this out in front if you want. So the negative of the square root of 2 minus the square root of 2 over 2. All right, let's take a look at problem number 6. So here we have the sine of pi over 12. Now again, if you have trouble working with radians, you can always convert this over to degrees. For these types of problems, it's probably not necessary because all you're doing is doubling this angle and dividing it by 2, right? So you can do the quick conversion if you need to. So let me say this is pi over 12 times 180 degrees over pi. So this is going to cancel. 180 divided by 12 is 15. So this is 15 degrees. So this right here would work out to be the sine of, again, you could do 30 degrees divided by 2, but I'm just going to use these radians here. So I'm just going to go ahead and say I'm going to double this. So essentially what you'd have is 2 times pi over 12. This would cancel with this and give me a 6 down here. So this would just be pi over 6 and then over 2 like this. Okay, so that's all you have to do. So same thing, just working with radians. So again, plus or minus, but in this case, pi over 12, 15 degrees, that's going to be in quadrant 1. So you want the principal square root. So the principal square root, and then we would say this is 1 minus your cosine of pi over 6, and this is over 2. Now the cosine of pi over 6, or the cosine of 30 degrees, is square root of 3 over 2. Let me just erase this here. So this is the square root of 3 over 2, and maybe I can make that a little bit better here. So this is square root of 3 like that. So I'm just going to multiply this by 2 over 2. And again, just distribute this here and distribute this here. Okay, so this is going to end up being the square root of 2 times 1 is 2. And then minus, the 2's would cancel, so you have the square root of 3. And this is over 2 times 2 is 4. So I'm just going to break this up and say this is the square root of 2 minus the square root of 3 over the square root of 4 is 2. Okay, let's take a look at problem 7. So here we have the cosine of 9 pi over 8. So again, you could convert this over if you need to. So I'll multiply this by 180 degrees over pi. I don't recommend it at this point. I think you should get used to working with fractions. So the pi's are going to cancel. If I do 180 divided by 8, I get 22.5. Let me just do this as a decimal here. And 22.5 times 9 is going to be 202.5. So this ends up being, I'm just going to write this here for reference, 202.5 degrees, in case you need it. Now, if you want to work with this in terms of radians, which is what I suggest, I would just say this is the cosine of, again, just double this, or you can double this if you need to work with degrees. So this is going to end up being 9 pi over 8 times 2. So this would cancel with this and leave me a 4 down here. So this is 9 pi over 4, and then this is going to be over 2. So we'll say this is equal to, again, your 202.5 degrees, that would be in quadrant 3. So in quadrant 3, cosine is negative. So you want to put the negative of the square root of, it's going to be 1 plus the cosine of, again, this angle right here, which is 9 pi over 4. And then this is over 2. Now for the cosine of 9 pi over 4, I would get the coterminal angle. So we think about 9 pi over 4. That's greater than 2 pi. So I'm going to subtract away 2 pi. So to get this in terms of having a denominator of 4, you could just write out 2 pi and then multiply by 4 over 4. So this would be 8 pi over 4. So 8 pi over 4. So the coterminal angle would be pi over 4, which is 45 degrees. So essentially the cosine of 45 degrees, or pi over 4, is square root of 2 over 2. So this ends up giving me the negative of the square root of 1 plus the square root of 2 over 2, and then this is over 2. So I'm just going to multiply by the 2 over 2 so that this denominator gets cleared out. So let's multiply here and here and here. And let's see what we end up with. So the negative of the square root of 2 times 1 is 2, and then plus square root of 2 over 2 times 2. The 2's would cancel, and you just get the square root of 2. And this is over 2 times 2, which is 4. So to finish this up, I'll say this is the negative of the square root of 2 plus the square root of 2. And this is over, the square root of 4 would be 2. All right, for the next few problems, the instructions tell us to find the exact value. So for problem 8, we're told that theta is greater than 180 degrees and less than 270 degrees. So that means we're going to be in quadrant 3. And this is for theta, not theta over 2. Then tangent of theta is given to us as 4/3. We want to find the cosine of theta over 2. So if you get this type of problem, the first thing you need to figure out is, where does theta over 2 lie? This is theta. You need to figure out theta over 2. So just start with theta being greater than 180 degrees and less than 270 degrees. And all we're going to do is divide each part here by 2 and simplify. So 180 degrees divided by 2 is 90 degrees. And then for 270 degrees divided by 2, that's 135 degrees. So what this tells me is that your theta over 2 is going to be greater than 90 degrees and less than 135 degrees. So I'm going to be in quadrant 2. Now, cosine is negative in quadrant 2. So just keep that in mind when you're trying to figure out what sign to use. So to find the cosine of theta over 2, we're going to use our formula, which is plus or minus in this case, because again, we're in quadrant 2 for theta over 2 and cosine is negative. I'm going to put the negative of the square root of 1 plus the cosine of, in this case, it's going to be theta over 2. So I just need to figure out what is the cosine of theta, plug in, and I'll be good to go. And we are told that the tangent of theta, which again is y over x, is equal to 4 over 3. Now that doesn't mean that y is 4 and x is 3. Again, you have to think about what quadrant theta is in. We said that theta was in quadrant 3. So in quadrant 3, your tangent is going to be positive, and that's because your y is negative and your x is negative. So in reality, this is a negative 4 and this is a negative 3. So coming down here, we would say that y is equal to negative 4 and x is equal to negative 3. So just keep that in mind. Now we need to figure out the r value here. And a lot of you can just eyeball this and see it's going to be 5, right? Because basically, forget about the negatives here. You have a 3, 4, 5 right triangle. So at this point, you can just put r as 5, and you could say that, okay, well, cosine of theta is going to be x, which is negative 3, over r, which is 5. So this is negative 3 over 5. Again, if you need to do this the long way, you can always say that r is equal to the square root of x squared plus y squared. So x here is negative 3 squared is 9, and then plus y here is negative 4 squared is 16. So 9 plus 16 is 25. And if you take the principal square root of 25, you do get 5. So that's where we're getting that r value of 5 from. Again, if you notice you have a 3, 4, 5 right triangle, you can just skip all that stuff. Okay, so now that we know the cosine of theta is negative 3/5, let me erase all of this and come back up here. I'm just going to plug in right there a negative 3/5 and basically just simplify, and we'll have our answer. So we'll come down here and say this equals the negative of the square root of, again, you could get a common denominator or you could just multiply by 5 over 5, whatever you want to do. So this is going to get distributed here and then here. 5 times 1 would be 5, and then minus 3/5 times 5 would just be 3. And this is over 2 times 5, which is 10. So this would be equal to the negative of the square root of 5 minus 3, which is 2, over 10. So that's going to end up being 1/5. Let me just do that right now. And what I'll do is I'll just split this up now and say this is the negative of the square root of 1 over the square root of 5. So the square root of 1 is 1. And really all we need to do is rationalize the denominator. So say this is times the square root of 5 over the square root of 5. So your final answer for the cosine of theta over 2 would be the negative of the square root of 5 over 5. All right, let's take a look at problem number 9. So here we're given that theta is greater than 180 degrees and less than 270 degrees. So again, that's telling me that theta, not theta over 2, but theta is in quadrant 3. So let me put this over here. That theta divided by 2 is greater than 180 degrees divided by 2 would be 90 degrees. And then we'll say, and it's less than 270 degrees divided by 2 would be 135 degrees. So theta over 2 is in quadrant 2, whereas theta is in quadrant 3. So here we're given tangent of theta. Notice it's positive because tangent is positive in quadrant 3. And this is 1/4, right? But essentially what's happening is in quadrant 3, the y values are negative and the x values are negative. So you have a negative over a negative, which gives you a positive. When we get to the tangent of theta over 2, again, theta over 2 is in quadrant 2, so the tangent values there will be negative. When I go ahead and do my formula, I want the negative of the square root. Let's come down here, and we'll go ahead and say, first and foremost, that you could pick any of these 3 last formulas here for the tangent of a over 2. I think that, although it's more difficult to simplify when you work with this first one here, you only need to find the cosine of, in this case, theta. So if I only need one of them, for myself, it's a little bit quicker. Maybe you have a hard time simplifying with that, so you could use the other 2. It'll be a little bit easier for you. So let's just go ahead and first find the cosine of theta. And again, when we think about this, theta is in quadrant 3. So I know my cosine value is going to be negative. Now, thinking about this, we have the tangent of theta is given to us as 1/4. Remember, this is y over x, but I'm in quadrant 3, so my y values are negative and my x values are negative. So you can do this and find your r as the square root of x squared plus y squared. So negative 4 squared is 16 plus negative 1 squared is 1. So this would be the square root of 17 like this. And so the cosine of theta would be x, which is negative 4, over r, which is square root of 17. You would multiply the numerator and denominator by the square root of 17. So you could rationalize the denominator there. And essentially what you would have is the negative of 4 times square root of 17 over 17. Now, if you don't like using this method, you can always use an identity. Remember, you could have done this by saying that tangent squared theta plus 1 is secant squared theta. And then you could just solve that for the secant of theta, take the reciprocal, and you'd have the same thing here for the cosine of theta. So let me get rid of this. And I'm just going to scooch this up here. So we know what the cosine of theta is. Now our goal is to find the tangent of theta over 2. Now again, this is in quadrant 2. So I want to say this is equal to the negative of the square root of, again, if we go back, it's 1 minus the cosine of a over 1 plus the cosine of a underneath the square root symbol. So let's go ahead and say this is 1 minus the cosine of, in this case, is theta, is the negative of 4 times square root of 17 over 17, minus a negative would be plus a positive. So this is 4 times square root of 17 over 17. Then this is over. Down here, this is 1 plus your cosine of theta. Again, since this is a negative, we'll write minus 4 times square root of 17 over 17. Okay, let's slide down here a little bit. This one's going to be a little bit tricky to simplify. Let me start by just multiplying the numerator and denominator of this complex fraction by 17. That way we can clear out the denominators to get things started. So let's say that this is equal to the negative of your square root, 17 times 1 is 17. And then 17 and 17 here, the denominator would cancel. So this is plus 4 times square root of 17 over 17 times 1 is 17, and then minus, and then here 17 and 17 would cancel. So you'd have 4 times the square root of 17. Now for the next step, I don't want to end up with a radical in the denominator. So what you would do, remember, if you have two terms down here and one of them has a square root, you can use that trick where you multiply the numerator and denominator by the conjugate of the denominator. So this will be multiplied by 17 plus 4 times square root of 17 over 17 plus 4 times square root of 17. So this is the same non-zero number over itself, so it's just 1. Just like I'm multiplying by 1, so no big deal. So let's put equals here. I'll put the negative of the square root of, let me wrap this in parentheses, so this is crystal clear what we're doing. So this right here, you can use your formula, x plus y quantity squared. So the first guy squared, 17 squared is 289. And then plus 2 times the first guy times the second guy. So 2 times 17 times 4 times square root of 17. So 2 times 17 is 34. And 34 times 4, that's going to be 136. So this would be 136 times the square root of 17. Like this. And then you go plus your last guy squared. So you would have to square 4, which is 16. And then multiply that by the square of the square root of 17, which is going to be 17. So 16 times 17 is 272. Okay, before I go any further, 289 plus 272, that's 561. So let's just write that right now. In the denominator, it's a little bit less work because you have a minus b times a plus b. So you can square a, so a squared, 17 squared is 289, and then subtract away the square of b. Right, so we just did this. 4 squared would be 16, and then times the square root of 17 squared is 17. 16 times 17, again, is 272. So what I'll do here is say 289 minus 272, that's going to be 17. So let's write that down there. So to finish up the problem, what I would do is check, is 561 divisible by 17? Well, yeah, 561 divided by 17 is 33. And then 136, is that divisible by 17? Well, yeah, 136 divided by 17 is 8. So you could say this is the negative of the square root of, I'm going to factor out a 17 from the numerator. So this would be a 33 here, and then plus an 8 times square root of 17 here. And this is over 17. So I'll cancel this with this, and I'll report my final answer. So this is the negative of the square root of 33 plus 8 times the square root of 17. All right, let's take a look at problem 10. So here, theta is greater than 180 degrees and less than 270 degrees. So theta is in quadrant 3. And we already know how this works out because the previous two problems had the same setup. So theta over 2 would be greater than, again, divide this by 2, you get 90 degrees. We'll say, and it's going to be less than, divide this by 2, you get 135 degrees. So theta is in quadrant 3, theta over 2 is in quadrant 2. So let's come down here. We have our sine of theta is given to us as negative 4 over 5. So the sine of, in this case, theta over 2 is equal to plus or minus the square root of 1 minus the cosine of theta over 2. So let's say this is equal to, again, we're going to be in quadrant 2. In quadrant 2, the sine value is positive. So this is the principal square root of 1 minus the cosine of theta over 2. Now, what's my cosine of theta? A lot of you can figure this out really quickly. Again, theta is in quadrant 3. Cosine is going to be negative there. If the sine of theta is negative 4/5, you should know at this point that the cosine of theta is going to be negative 3/5. Why? Because again, you're working with a 3, 4, 5 right triangle. So the negative of a negative is a positive. So this is plus 3/5. And again, if you want to do this the long way, there's so many ways you can do this. You can use sine squared theta plus cosine squared theta equals 1. You could do the fact that you have sine of theta is equal to negative 4/5. So you know that in quadrant 3, the x values are negative and the y values are negative. So you can say that your y here is negative 4. Your r here is going to be 5. And your x here is going to be negative 3. And again, you can just do r is equal to the square root of x squared plus y squared. So negative 3 squared is 9, plus negative 4 squared is 16. 9 plus 16 is 25. So r is the principal square root of 25, which is 5. So again, that's where that's coming from. Hopefully at this point, when you start seeing that, something with a special right triangle involved, you can quickly get the value. So what I'll do here is multiply this by 5 over 5. So this gets distributed here. So we'll say this equals the square root of 5 times 1 is 5. And then plus 3/5 times 5 is just 3. Let's just say 5 plus 3 is 8 now. And then this is over. 5 times 2 is going to be 10. So for 8 over 10, they're each divisible by 2. Let's just go ahead and say that's going to be 4/5, right? 8 divided by 2 is 4. And then 10 divided by 2 is 5. So let's write this as the square root of 4, which is 2, over the square root of 5. You need to rationalize the denominator, so multiply by the square root of 5 over the square root of 5. Let's make that 5 a little bit better there. And so the final answer for the sine of theta over 2, this is going to be 2 times square root of 5 over 5. All right, let's take a look at problem number 11. So here we're given that theta is greater than 90 degrees and less than 180 degrees. So theta is in quadrant 2. Now we're given that cosine of theta is negative 11 over 17. And that makes sense because cosine values are negative in quadrant 2. But in terms of theta over 2, we're trying to find the sine of theta over 2. So that would be where? So theta over 2 is greater than 90 degrees divided by 2 is 45 degrees. And it's less than 180 degrees divided by 2 would be 90 degrees. So theta over 2 is in quadrant 1, whereas theta is in quadrant 2. So keep that in mind. So sine of theta over 2, again, if you go back, the sine of theta over 2 would be equal to plus or minus the square root of 1 minus the cosine of theta over 2. So let's say that this is equal to, again, we're going to be in quadrant 1 for this theta over 2. Let me make this 5 a little bit better. Sort of looks like a 3 there. And then I'll say this is the principal square root of, you have 1 minus the cosine of theta. Now the cosine of theta is negative 11 over 17. Minus the negative is plus a positive. So let's put plus 11 over 17. And this is over 2. So I'm just going to multiply this by 17 over 17. So distribute this like this. And we'll say that this is the square root of 17 times 1 is 17. And then plus 11 over 17 times 17 would just be 11. So 17 plus 11 is going to be 28. And this is over 2 times 17, which is 34. Now 28 divided by 2 would be 14. And then 34 divided by 2 would be 17. So this gives me the square root of 14 over the square root of 17. So I'm going to multiply this by the square root of 17 over the square root of 17. So this equals 14 times 17 is 238. So this would be the square root of 238 over square root of 17 times square root of 17 is 17. So your sine of theta over 2 is the square root of 238 over 17. All right, for the next few problems, the instructions tell us to verify each identity. So for problem 12, we have secant squared theta over 2 is equal to 2 over 1 plus cosine of theta. So I would definitely say that this side right here is simpler. So let's flip this and say 2 over 1 plus the cosine of theta. So that's what we're trying to get a match on. So this would be equal to, let's just write this. So the secant squared of this theta over 2. So the first thing I'm going to do is say that this is 1 over my cosine squared of theta over 2. Now I think it's probably better to write this like this so it's crystal clear what's going on. Now the next step, if I think about the cosine of, let's say, theta over 2 is equal to plus or minus the square root of 1 plus the cosine of theta over 2. So let's plug that in for the cosine of theta over 2. And again, the squared here is on the outside. That's why I wrote it like that so it's crystal clear what we're going to do. So we'll say this is equal to 1 over. Again, I'm going to wrap this and square it like this. This is plus or minus the square root of 1 plus your cosine of theta over 2. So let's say this equals 1 over. If I square this guy here, I'm just left with the radicand. So I'm going to have 1 plus cosine of theta over 2. And then basically the last thing here is just to say that I have 1 divided by this. So I'm going to write this as 1 times the reciprocal of this. So 2 over 1 plus the cosine of theta. And let's just finish this up and say this is 2 over 1 plus the cosine of theta. And we're done. Okay, let's take a look at problem 13. So here we have sine squared theta over 2 is equal to tangent of theta minus sine of theta over 2 times the tangent of theta. So again, lots of different ways to work this. I'm going to consider this left side more simple. And so what I'm going to do is work on this right side here. And so to do this, I'm going to multiply the numerator and denominator by the cotangent of theta. So let's write this out. The tangent of theta minus the sine of theta over 2 times the tangent of theta. So times the cotangent of theta over the cotangent of theta. Now, you can do this a different way. The reason I'm doing this is because the cotangent of theta times the tangent of theta is going to give me 1. So I'll be able to get a 1 here and a 1 down here. And then sine of theta times cotangent of theta is cosine of theta. So let's come down here and do the cotangent of theta times the tangent of theta. So I'm just distributing this here. And this is going to go here. And then minus the sine of theta times the cotangent of theta. This is over 2 times the tangent of theta times the cotangent of theta. Let me make this theta a little bit better there. Cotangent of theta times tangent of theta in each case is going to be 1. So that's 1 there. Sine of theta times cotangent of theta. Again, you could write this as the cosine of theta over the sine of theta to make that crystal clear. This is going to cancel, so you have the cosine of theta. So this is going to be 1 minus the cosine of theta over 2. We want sine squared of theta over 2. So sine squared of theta over 2. How can we get that? If you just had the sine of theta over 2, that would be equal to what? This is plus or minus the square root of 1 minus the cosine of theta over 2. Right? I'm just getting this, again, from the handout here. So the second guy, sine of theta over 2 is equal to plus or minus the square root of 1 minus the cosine of theta over 2. Now, what I want is sine squared of this guy. Again, it's probably easier just to notate it this way. So I want this guy. Well, basically, I'm already there, right? So if I go plus or minus the square root of this guy squared, right, it's going to cancel the plus or minus square root part, and I'm just left with this. So all I really need to do is say this is plus or minus the square root of 1 minus the cosine of theta over 2, and then I'm just going to square this to undo that, right? So I'm right back to that. So once I do this step here, I can replace this with my sine of theta over 2. Again, being squared, you could do it like this, but the original notation was like this. I know a lot of people get confused by that, so I'm just going to say this is sine squared of theta over 2, so we're done.